up with the time variable. Secondly, it has some seasonality. After some time, there is a spike, then values, then spike, then values, then spike. And the
Yes,
third
sir.
important thing, which is actually bothering all of us, is in between you have gaps. That is, there are some missing values that exist in the data set.
Right, sir.
So the first job that we have to do is we have to handle this missing value. So, ma'am, I request you to kindly click yes, Apurva Kumar sir.
Sir, actually in the graph, the both axes showing the passengers. Is that the number of passengers? But both axes should not be same.
Yes, it is basically right now we are it is on the left hand side. It is basically showing the passengers. It is
Yeah.
the time variable. We can change it later. It is not passenger. It is the blue line represents the number
X-axis
of
should be
passengers.
something else, a timeline like
This
that.
is 0, 1 to 20. Basically, these are the dates. We have to change it if we wish to.
Okay.
In x-axis, we have not defined anything. If you see at the left hand
Yes, sir.
side x-axis column, ma'am, I request you to
Okay.
kindly add month.
Month. Yes, sir.
Okay, sir.
Okay, thank you.
Okay, sir.
Okay, yeah.
Included
Right now it
month
is.
in that. That's what. Now, ma'am, we are
Yes, sir.
we are through that. We have passengers on y-axis and months on the
X-axis.
x-axis. We can here we have simply written the year. If we want to change the attribute type, we can do that. Now, ma'am, I request you to basic understanding, basic characteristics, basic nature of the data, and one problem, that is your missing values.
Missing
and
values.
easily visible. Ma'am, we can also see the box plot of this data. So instead of line, you can see or you can click box plot.
Box plot. Okay, this one. Plot. Yes.
Yes, box plot. So box plot is also giving you some values. In box plot, this is the box. The square one is the box. These lines above box, vertical lines, are known as whiskers, and these are the top and bottom values. So we will see that also later on. But now the first job that we are expected to do is we have to. Yes, Rajni ma'am. Acha, she has left. Okay. Okay. Then go to the design part, ma'am. On the tab you have design.
Sorry. Yes. Sorry. Yes. Yes.
Design.
Yes.
Please click
Yes,
design.
Yes.
So right now design is empty.
Yes, sir.
So you simply click air pass and drag it in the process area.
Okay.
Wonderful. Anyway.
Yes, sir.
Now what we are interested in, in handling the missing values. So kindly search replace missing values on the tab, that is on the right hand side below cross. A search option is there. Yes.
Find data. Yes, sir.
Yes. Find data. Please search replace missing values. Yes.
First
replace
one.
missing values, the first option. Drag and drop it. Yes. Move a little bit to the right side. So
Right side.
Yes.
Yes, sir.
Now.
Yes, sir.
To please click the output of retrieve data bubble to the input of replace missing value.
Here I click, right, sir?
Yes, you drag it and connect it to the input of replace. Yes, on the left hand side we have input, and on the right hand side we have output. Great,
Yes,
ma'am. Now the next thing is you have to connect EXA, that is example, to RES.
Okay.
Fine. So our multiple jobs we have already completed. Now what is expected, that we have to define what values we want to impute, what method we want to adapt as far as imputation is concerned. Imputation or missing value handling is concerned. So firstly, you will see that on the parameter side we have attribute filter type. You will find that all is selected.
Yeah, this side. Yes.
Side parameters.
Yes, sir.
Right.
All.
Keep it all, because we are interested to handle all variables.
Right.
Then we have default. If you click the green arrow in front of default, so it suggests that which value is to be, which method is to be selected. So average is the default value method that will help in imputing those missing values.
Right, sir.
If you will click the arrow where average is written above that, so you will find that minimum, maximum,
Zero,
zero, or a
and
value that you want to give. A value that you want to give. You want to give, suppose 200 as a value. So at all missing values, 200 will be will replace the missing value. You want to give minimum value, which, but yes, with this method, the concern is that you can only select these options which are available. And in
Right.
most of the cases, whenever we talk about any data analytics, data mining, or business analytics software, there are restrictions. Otherwise, we have to go to the coding part of RapidMiner, SAS, Excel Miner, or any other software which are available as far as non-programming software are concerned. So, ma'am, you select maximum, average,
average, yes, sir.
and then you please press run sign. RU and run is the blue rectangle available on your screen on the left side below, before, after, save. Move
Sorry,
your
sir.
mouse pointer.
So this one,
Yes, ma'am. This is the run option.
run. Should I press
Yes.
it? Click.
You simply click it.
Yes,
Run.
sir.
So now you will find that if you now see the statistics, you will find that at all missing values, the average value has been taken care, and all missing values are filled by the average.
Right, sir.
Right? When now you go to the statistics, you will find that there is no missing value.
Should I go?
Yes, click statistics.
Yes, no
You will
missing.
find that months missing value 0, passengers missing value 0. You go to visualize again, click the blue sign. Yes, click the data visualization.
Yes.
You'll find that all values are open. Yes, Kaushik sir, please.
Sir, good morning.
Namaskar sir.
Namaskar. Sir, my question is this, the software calculates the value based on an average or by some other means?
Average, sir. We have informed that you calculate values by average. If you want to give, so there are mean, average, minimum, maximum, and mode, and your value also. If you wish to give your value, if you wish to give some value that you want to put on the basis of some calculations you have done at the back end, you can also give. So all missing values will be handled by that particular value that you have provided.
So the best way is an average, sir.
No, it depends, sir. If you have something where we have frequency, or in numerical data, if you are talking about frequency, then you will be giving that value, or you will be providing mode of that. If you want that, no, sorted value median should be provided. Then it is basically dependent on the type of data, nature of the data. You will be selecting an appropriate method.
Thank you, sir.
Ji, sir. Ma'am, you have already seen this histogram. You
Yes,
can
sir.
see the line chart. I think you have seen the line chart also.
Yes, sir. Yes, it is a continuous now.
So you will see that all values are filled. So this is one method. Ma'am, you go to the design.
Design. Yes, sir.
Now, this is the simplest method of handling missing values. Now, my request is, you have one data. Ma'am, you also please do it. I'll tell you which
Yes,
data
sir.
set I'm talking about.
Yes, sir.
Just a minute, ma'am. Yes, there are two more data set.
Should I import them, sir?
Just a minute, ma'am.
Okay.
Yes, ma'am. There is another data set known as gold NSC price. I request everybody to kindly import gold NSC price. Ma'am, here the important part is
Yes.
that CDEFG is not required. So go to the previous one.
Okay.
Previous. And
And-
here it is A and B only. So please
Okay.
select cell range A and B only.
Yes, sir.
Great.
Sorry.
Next.
Sorry. Okay. Next.
Ma'am,
Sorry.
go to the previous
Sorry,
one.
sorry. It was A1 to B1, it should be, right? No, A and B.
A to B. A colon B.
Right, sir. And
Great.
next.
Next.
Again, next.
Right. Next, ma'am.
Finish.
So this is your gold prices and NSE index prices. Gold prices and NSE index prices. Now you have to handle or manage the data. You see the visualization statistics. If you click statistics, you will come to know that whether there are, yes,
Missing.
for gold prices,
Missing.
5 missing values, and for NSE there are 4 missing values.
Yes, sir.
So when you will find the graph, if you will see the line chart, you will find that even though there are values which are very high, you will find that there are few missing values at the bottom at near x-axis. There are few values which are missing. If you see value column instead of NSE index, you select the next one. Yes, gold price also.
Yeah.
Select gold price. Right.
No,
Right,
I just say
blue
apply.
arrow, right blue arrow.
Yeah. Okay. And apply.
Apply.
Okay. Yeah. Both.
So in second, in blue, that is gold prices also, you have green line which are missing. So please handle the gold prices, only the gold prices missing value. I request everybody to handle missing values with reference to gold prices only.
I select it here, sir.
Ma'am, go to no. You have
Sorry.
only seen. You have to now handle gold prices only. So go to the design.
Yeah.
New design. For new design, you have extreme left below file, white color paper. Yes.
Yes.
If you want to save previous, no ma'am, no blank,
Sorry.
blank process. Yes. First click.
Open a process.
That open. No.
Sorry.
Yes.
File new process.
New process. Yes.
Blank process.
Blank process. You want to save previous one?
Yes. Yes.
Any name?
Yes.
At local repository.
Yeah.
Give a name to it.
File. Okay. Yeah. Yeah.
Now ma'am, drag gold
I
NSE price.
Yes.
Ma'am, we are not interested
Huh.
to change NSE prices. We have both prices. We have NSE price and we have gold prices. But we
Right.
are only interested to handle missing values of
Missing.
gold price.
Right, sir.
So just a minute. Are we together? Rest all participants.
Yes, sir.
Yes, yes, sir.
Yes, sir. I am there.
Okay. Just because yesterday Apurva sir was speaking and rest all ma'am listening. Today Sonali ma'am is speaking, so rest all are listening. So just to understand whether we are together or not. Please, one more time. Are we together?
Yes, sir.
Yes, sir.
Yes, sir.
आप लोग मेरे को नितिन भी बुला सकते हैं. मैं आप लोगों से I am younger than you, so you can call Nitin. We are together. Okay. So, ma'am, here we have to select only gold prices. So there is an attribute, select attribute. So again, the place from where you have searched, replace, type, select.
Sorry, I am going blank. Oh yes, sorry. Yes, sir.
Yes.
I select here what?
Select attribute. Yes. Yes.
Attributes,
the first option.
the first one. Yes.
Drag and drop. Drag and drop.
Yes.
Connect the output of retrieve data to select attributes. And now in select attributes, click select attribute operator. Yes. So here we are selecting one attribute from multiple attributes. So here attribute filter type will be subset, because from a pool we are selecting a few attributes. Right now we will have single attribute. So on the right hand side in the parameters we have attribute filter type. Right hand side of the screen.
Yes.
All click subset, because from multiple attributes we are selecting a single attribute.
Yes, sir.
And out of those attributes, currently we have only 2 attributes, but we may have multiple attributes also. So you please click the select attributes option which is available on your screen. Yes. After selecting this, we have two attributes, gold price and NSC. You
NSC,
select
yeah.
gold price and click blue right arrow, right, then apply.
Select attribute. Okay.
Yeah. So now what is happening? If you have 100 attributes and you want to select only 10, so you select only those 10 attributes. So for your study, these 10 attributes will be applicable. Rest of attributes will be of no use, but it will be there in the data. Then please click EXA to RES. No example data set is
Sorry.
Can you repeat, sir, the select attribute? From the select attribute, how you can go to select? Select attribute.
Okay, see, select attribute. The gold was here. We dragged it. We selected the gold price and we clicked
undo it.
right
Then you
arrow.
undo it. Gold, click gold and then left arrow. Gold and left arrow.
Sorry, left arrow. Yeah.
The
So this is what we
type
did.
filter.
You want me to go back again, sir?
Apurva sir, is it okay?
See, so select
No,
attributes.
actually, in the select attribute, I have to type the subsets. Okay.
Yes, subsets,
That
yes.
is missing.
Yes.
In case of all, I have to type subsets.
Yes.
Oh, then I have to. Okay.
Because sir, we are selecting few attributes from the
Few
pool.
attributes.
So from superset, we are selecting subset, few values.
Few values. So
Ma'am,
I
okay,
see
gold
gold
prices.
price. Okay.
Now gold price, right arrow and apply.
Ma'am, we are not right now handling missing values. We just want to see whether what we wanted, whether we have done it or not. Now, please
Yes,
please press the play button or run the file. Yes, we have only gold prices. You will find that row number and gold prices. VSC, NSC values are not there. So we are okay. We are done. Now go to the design. Go to the design and please delete select attributes and result link. If you show.
Sorry. And this one.
Yes, cross.
Okay.
Now handle missing values. Again, you have to search replace missing value. I request to kindly mute your system. Mixie is working. Some juice is going on. Replace missing value.
Yes.
Drag and drop. Connect example of select attribute to the input example of replace missing value. So output bubble are always on the right hand side and input bubble are always on the left hand side. Then example to the result. This example of replace output to the result. And in replace missing values, again you can click replace missing value operator, which is in the process. And on the right hand side, you have various operations that can be performed. But because we have kept our recommended operators online or recommended system online, so open, so it will always recommend you that what while performing the operation. Again, average is the value. If you want to select something else, see what all values are there. You have maximum, minimum, average, zero, none, and so on. So if you are giving, suppose you are giving, ma'am, we are not saying that this is the correct answer. Suppose you are giving minimum value.
Right.
So it will, what will happen? It will check the minimum value and replace all missing values by the
minimum value. Okay.
Please run it. Yes, Kaushik sir.
Sir, I have a basic question here.
Yes.
I mean, can we go back, madam, to the design part?
Yes, sir.
Sir, we have an input and an output for all these three things. I mean, retrieve, select, and replace missing one. Now, on the right side, we see mini bubbles, one of which is example.
Yes.
The other two bubbles signify what, sir? And what if we connect those bubbles to the results?
Sir, if you will directly move your mouse pointer to the bubble, it will give you the answer, the first answer. So, ma'am, you go to the first one, EXA, no, replace missing value, first output EXA. Replace missing value. If you click, it will give you example data set. So example data set is the data set that RapidMiner creates where values are stored, firstly. And you can get the complete details related to what we are doing. Ma'am, go to the ORI. It is the original data set. This is the original data set that we are talking about. Example data set mein we have missing values also.
Missing values added. Yes, yes.
Kindly connect ORI to the result.
This one?
ORI to the result.
This result or the...
Now run it. So you will find, Kaushik sir, that there are two columns. One column containing original values with missing, and second will be, ma'am, it is not displayed. Yes. Example data set, ma'am, move to the next tab. No. In results only. In results only. Next to design. No. Next to design, ma'am. Oh.
So,
design,
yes.
Taskbar. Yeah.
Go to results. Next one.
Results. Sorry. Yeah.
Yes. Then we have example replace missing value, ma'am. You have next tab. Here only. Example set attributes. And next.
Sorry. I'm not getting you, sir. Where do I go?
Yes, ma'am. This one.
Yeah.
Yes. Click it.
I
Next
click
tab.
here. Okay.
Yes. These are after missing values. After missing values. And when you click example, select attributes. So this is the outcome. Then click example set local repository. So then yes. So these are the various outcomes which are coming, sir. Right, sir?
Yes, sir.
A design.
Sir, and sir, what is the third bubble, sir? In that, one is example, one is original.
Yeah, this is pre-RE.
Ma'am, please click. This is pre-processing model. Right now we are not using any model, but it is a pre-processing model. We are not bothered with that. So leave it right now.
Okay. Thank you, sir.
So this is another example that we are using for handling missing values. Only handling missing values. But if you see there is another problem with the data, and what is the problem, that we will check just now. So instead of going ahead, my humble request is at your end, kindly complete the third data set which is with you, cleaning price data, and tell me your observations. Then we will move forward.
Yes.
I request everybody to kindly work on the close prices. So whatever data we have taken financial data, mostly air pass data. We have taken financial data. The purpose is quite simple, that whenever we process any financial data, it is very important that the data should be clean, the data should be processed, the data should be neat, the data should not be dirty. Ma'am, you please close all these. Yes.
Yeah. So if somebody wants to volunteer, I mean, because
anyone? Yes.
Yeah.
Anyone?
Those who want to try, I can stop sharing then.
Anyone? No, we have to work on another model also, so we can continue. Anyone who is interested?
Yeah, I can try.
Okay, so I'll stop sharing. I'll stop sharing.
Sonali madam, I don't know why you left, but you left at the right time, because Patel sahab now will be abusing me. What data you have given me? So, okay.
No, I thought if somebody wants to volunteer.
Patel sahab, please share your screen.
Yeah.
Thank you, Sonali ma'am. Thank you, Apurva ji, and now thank you, Patel sahab.
Yeah, you want me to clean the closing price?
I request you to share your screen.
Yeah, is it visible now?
Yes, it is coming. It is on the way.
All right.
So, sir, you have to now clean the data, and the name of the data set is cleaning price data.
All right. So I'll do that.
So, sir, you have to take A to B only.
Yeah, I'll do that. All right, so closing price has 7 missing value.
Right.
So
here we don't require select attributes, because, sir, we have only one attribute, date, and so no requirement for. If we have multiple attributes, then it makes sense. So you delete that.
But even the date was there as a column. So does it make sense or it will not make any sense?
For closing price, I think date will make sense.
All right. So we need not to select the attributes.
Not required. Because in financial data, in other data sets, when time series data, time and date is required. That's why.
Okay. All right, then I think
All, no sir,
all would be okay,
Here
right? So
all will be
we
there
have-
because we want to select all attributes, data value. We want to handle them.
So I think that's it. But still there is an
I am very badmas. You have some special characters also.
yes, there is an @.
So there may be @, there may be some special characters, there may be some alphabets, there may be some errors. What to do?
So
Anyone?
first of
Sir, don't worry. Don't worry. Don't be in worry. I'm with you. So you please drag replace missing value to a little bit to the right side. More right, more right, more right, right. Then delete the link between retrieve cleaning and replace missing. No, not this one. Before that. Yes. And search only replace. Not replace missing, but only replace. Drag and drop. Now connect the output of cleaning process to the replace and output of replace to example of. So it will be activated with example is example, output and output. So it will be there. Now, sir, please click replace. Replaces. You have already clicked the replace operator. Go to replace what? No. Please click replace operator only.
All
Replace
right.
missing. Yes. Then go in replace operator. You will find there is replace what. Replace what. The rest all things will be same. And then there is a no. Don't do that. Then there is a search sign. That yes. After clicking this, you will find a wonderful list. So you can click the drop down option, and you have at the bottom you have punctuation character @ special characters. Yes, add it. And then so whenever you have any of these characters will be replaced by at the bottom replacement value. We are not replacing it with a value. We are keeping it blank. We are treating now it as a missing value. Are you with me?
Yes, sir.
So just to interrupt you, I did not get where you got this regular expressions from.
Yes, sir. Please cancel it.
Sorry.
Now, ma'am, click replace operator.
Yes, I did that.
Then in replace what you have this
Yes.
micro. Yes.
Yes.
Then regular expression. Then you have an arrow.
Okay.
At the bottom.
Okay.
Whether you got it?
Yes, sir. The last one, punctuation character.
Yes, punctuation character.
Right, sir.
Then,
Right,
sir, please apply.
Punctuation character. Yeah.
Yes.
And replace with what?
@ hyphens, inverted commas, exclamation sign, left bracket, right. Everything will be discarded. Now, sir, by the grace of Almighty, you please click the play sign. Run this process.
Done, sir. So my question is,
Yes, sir.
when we have a large data set, how we identify that whether we have entered a missing value with @ sign or 999 sign or blank sign?
Sir, then we don't have to see every time that whether we have data set or not, missing values or not. We have to apply those things prior to it. Rather, when we see the basic characteristics of missing values and outlier, so we will check the data set through graphs and chart. That's why it is said that whenever we apply any modeling or any method in data analytics part, it is important to first see the data, to understand the behavior of the data, to see the nature of the data, to check whether if it is a continuous data, whether a normal distribution is followed, whether high kurtosis is there or not. So after that only we can apply a suitable method, suitable model. So here also you have
I just want to verify, sir, whether that feature is available, because what I used to do in Excel, when we do a sorting, it shows the same box, right? So do we have something like that feature in?
I have not checked it, but when we talk about cleaning, you directly put replace and replace missing values.
Okay.
If there is any such values, rather missing values will already be shown to you when you drag the data and see the properties. So it will show you that whether missing values are there or not. Rather, if you have some special characters, so real or numerical type data will be converted into polynomial data. So you can understand that in the data set, there are values are seen to be numerical, but they are not numerical. They are either alphanumeric characters or they are images or text characters.
Right.
It is visible.
Okay.
You do it. We will discuss it tomorrow as well. Okay.
Right.
So here we have done something interesting. Now my humble request is, sir, kindly go to the result. Go to the statistics and the left hand side statistics. You will find no missing value. No, this is close price. You will see that it is a polynomial. Are you able to see, sir?
Yes, sir.
Yeah, it is. This is because that initially we had values which was non-numeric in nature. Sir, go to visualization. Are we able to see visualization? Go to the box plot. It seems that okay, you have selected date and time, sir. Please select box plot.
It is already selected, but I think there is some problem.
Because it is non-numerical value, sir. It has selected the wrong value. It has selected the wrong value because it was initially a polynomial. So either we have to change the data type of the value. Otherwise, what you were talking about, that how will you know? So this shows that the value is a non-numerical value. So there is a method using servo preparation where we can directly change the data type, but let it be. अभी इसको इतना ही करते हैं. Otherwise, we will be missing whatever is required. So I will request Pranjim Mule sir and Jesh sir to have a full day session on this. So sir, you leave everything. Now go to the previous data set that you have cleaned. Previous. I think you must have saved that. Closing, cleaning NSC BSc, gold NSC, sir.
Gold NSC. Okay, and you want me to open it in a new file?
Yes.
All right.
Okay, and replace missing value. Please handle the missing value because
you want in both NSC and gold price, or you want
replace missing value series? It is replace missing value only.
Right.
Delete it. So delete it. This is not replace missing value. It is replace missing value only, not series. So I want only on gold prices.
Okay, so you want
first one, replace missing values, not series.
Okay, all missing.
So there may be an operator known as replace missing values only, not all, no other abbreviation, nothing.
Replace. So I am getting this only.
No, you type missing, then it will come.
Please type missing.
Okay, replace missing values.
Yes. But before missing, you have to put select attributes also.
Right. So
because we are only interested in gold prices. Okay. Now select attributes. Select the operator. No, select the operator.
Okay,
no. Select the operator. Missing value. Yes. Subset. Then select gold price. Yes. Apply. And then output of select attribute will be connected.
Sorry, your voice is not coming.
Now select attribute example will be connected to input of replace missing value example.
Right, sir.
Yes, sir. And then example of replace missing value connected to the output. And in replace missing value, you have taken average. Run.
Shall I run?
Yes, please run. Now, these things are done. Now go to the visualization. Go see the box plot. What do you see?
Where should I go?
It is said that if the whiskers means the vertical line, if the whiskers are of same size, then we will say that the distribution is normal. Firstly, distribution of data, numerical data, continuous numerical data is normal. Secondly, if you have a whiskers which is very high, very big, either lower or higher side, then it indicates that there are few values. If the whisker size at the bottom side is bigger or larger, then it means there are few values which are very less than the median or mean of the complete data set. If you have some values which are very high than the average or median, then we will say that upper whisker will be very large. So here you will find that your bottom whisker is very big. It means there are few values which are very small in nature, very small, and that may create the outliers. That may create an outlier. So you can understand that suppose in the case of gold prices only, you are saying that the median is 28,000, the maximum value is 31,000, and the minimum value is 20,000. So you may say that for a given range, the gold prices are falling somewhere around 28,000, 29,000, 30,000. Achanak se the value moved to 20,000. Whether it is correct within a day or so, rest all values are within the range, but there are few values which are very less. So is it correct? For that, we have to first find out whether we have outliers or not. In the case of rapid miner also, there are outlier operators, but we will not use those operators. Very complicated and मेरे को भी बहुत तकलीफ हो जाती है कभी सोचने में उसके लिए, तो घबराहट हो जाती है. So let us remove that option. So we will using this box whiskers plot and box whiskers method, we will simply apply method, and the method is you can note down somewhere. I will go through the slides quickly, but my humble request is everybody, Patel Sahab, Sonali Sahab, Apurva ji, Vikas ji, Chandrasekhar ji, Pranjal Sahab nahi, Joshi ji, and rest all जो screen पे दिख रहे हैं मैंने उनका नाम लिया बस. I request you to write an equation. Q3 plus 1.5 Q3 minus Q1. Q3 plus 1.5 into within brackets Q3 minus Q1. First equation. Second, Q3 plus 3 into within brackets Q3 minus Q1. So these two equations will give us upper outlier and upper extreme outliers. Whatever values will fall above that, it will give you extreme outliers. And if we have an equation Q1 minus 1.5 Q3 minus Q1 within brackets, Q1 minus 1.5 within brackets Q3 minus Q1, and Q1 minus 3 times Q3 minus Q1 within brackets. Q1 minus 3 times within brackets Q3 minus Q1. So it will give you outliers at the lower side, or lower outliers at the below side. So here we have 4 equations. So how to know what is Q1, what is Q3, how to calculate it? So we can simply calculate it by Excel also, but here the results are given in Excel also. Whenever we have a box plot, we can get the value. So here when you click it, when you move your mouse pointer, so it will give you maximum value, then upper quartile or Q3, both are same, or 75 percentile. So if anybody asks you 75 percentile, so it means that person is talking about Q3. If the person is saying upper quartile, it means that. So what is upper quartile? Upper quartile is median value and all values above median values median value. So median is 28,000. So we will say that this is the total data value. This is the median. So median and median of all above values will be Q3, that is 75%. Median and below values, median value is basically lower quartile, which is 25%. Upper quartile, 75% or Q3 is 30,468.5. Lower quartile, 25% or Q1 is 26.863. And what is Q2? Q2 is our median, which is not required. So you have to simply put values. So instead of Q3, you have to put values 30,468.5. In place of Q1, you have to put values 26.663. You have to calculate values. There will be some values that will be calculated. So you will say, suppose you are writing Q3 and Q1 values in Q3 minus 3, Q3 plus 3 into Q3 minus Q1. So whatever values are above Q3 plus Q1, those values will be outlined. Whatever values are below Q3, Q1 minus 3 into Q1, Q3 minus Q1 will be lower quartile, lower outline. So, and this Q3 minus Q1 is known as interquartile range. This is known as interquartile range. So my request is using paper, pen or Excel. Rather, we can do it here also. There is an option of turbo preparation, but we are not doing right now. The turbo preparation thing, calculation will be done in fraction of a second. But using pen, paper, please tell me Q3 plus 3 into Q3 minus Q1, what is the value? And Q1 minus 3 into Q3 minus Q1, what is the value? Please. You can write in the chat box also. Not a big exercise. No, upper quartiles. Kunal Saab has written 40. No, sir. This is not 35,876-40. No, we are saying, are you with me? Everybody with me?
So it's a two range, I mean.
Yes, sir. Yes, sir.
Yes. So you are telling he is telling two values. So if we are saying Q3 plus 1.5 Q3 minus Q1, that is Q3 minus Q1 is interquartile range. So if any value which is above 35, including 35, 876.75 is above than that, so we will say that it is an outlier. But any value which is higher than 46,696, 93.25, then it is extreme outlier. It means something serious has happened as far as gold prices are concerned. Similarly, any value which is below 21,454, then it is a lower quartile, a lower value, lower outlier. Not lower quartile, lower outlier. And any value which is below 10,638, then it is extreme outlier. Whenever we have any value which is below 10,000, so it is extreme outlier. So we have to examine that value. We have to examine that value, whether that value is an error or actually some business. So without seeing the business situation, we cannot conclude. We cannot conclude that whatever is happening is correct or not. So we will see that there is a value which is 9,000. On all days, the values are happening 20,000, 28,000, 30,000, and so on and so forth. But when it is higher than, lower than 10,000, then it is a concern. Either there is an error in your system or there is something. So it is not quartile. Q1, Q2 are sir. Q1, Q2 nahi. Q1.
Sir,
Q2,
I'm sorry. It is equation 1, equation 2.
Okay, so equation 1 is 42,000. So something wrong has done by Patel sir. So 42,000, it means any value which is above 42,000 will be extreme outlier. Any value which is above 37,844 will be outlier, upper outlier. Similarly, for the lower values, that is Q1 minus 1.5, Q3 minus Q1, and Q1 minus 3 times Q3 minus Q1 will give you lower value. So anything which is below or above these values will be treated as outlier or extreme outlier. Higher outlier, higher extreme outlier, or lower outlier and lower extreme outlier. Are we together?
Yes, sir.
So, sir, I request now. I request you to. I request Patel sir. Patel sir, I request you to kindly unshare. Thank you for your support. Nice. So I will quickly go through what we were talking, and these things are really very important. Why very important? Because for the financial data, if you are rather for REST data set also, whenever we work on business analytics, we always ensure that the data is of right quality. So we have seen the graphs, we have seen the box plot. So this I was talking to you people in my previous slide when Kunal Sahab was sharing that if this is big, this is known as whisker. This is lower whisker, this is upper whisker. So if whiskers are smaller or bigger, so one thing is suggested that the data is not normally distributed. Firstly, then we will say that this is your lower quartile, and lower whisker, and if lower whisker is bigger, so it means you have few values which are very small, and you can easily, it is evident also. You can see that there are few values which are very small here. There are few values which are very small. So when we have very few small values, there are possibilities that there may be lower outliers. There may be lower outliers, and when we have lower outliers, then in that situation, things will be in different shape. Just a minute, there is a phone call. Just a minute. This has happened when you sit in the organization, then director and deans used to call you. So no worries. Okay. Are we together? We are together.
Sir,
G.
Sir, can you please repeat this equation 1, 2, 3, 4? And
just a minute, just a minute. I'm coming on that. We
Yeah.
have first done it and then we are working on this. Just a minute, I'm coming on that. So, so ultimately, any value which is below this, any value above this will be your outlier or extreme outlier. That's it. So we have to see that whether these outliers are business situation or these are errors. So in my case, in my wife's income tax department case, it was an error. So I'm moving it. So these I'm moving it quickly. We have already discussed it. We have discussed most of the things and quartiles, Q1, Q3, median value, sorted list, center values, the median value. And so we will simply say that this, if suppose this is median, so this will be your Q2, and the median between this will be Q3, and median between this will be Q1. This we were talking about in our previous deliberation, and then we have interquartile range is 75 percentile minus 25 percentile. So if we have 87 as the Q3 value and 61.5 as Q1, so 25.5 will be Q3 minus Q1, which is your interquartile range. So we have already said that outliers may be actual value or it may be an error. We have to understand it is not Excel minor, it is rapid minor. We have to understand that what is the outliers, whether we have outliers or not. So these are the outliers that we have calculated. Outliers, lower or upper outliers, Q3 plus 1.5, Q3 minus Q1. Any value above, suppose we have this equation is generating a value of 695.625. So we will say that any value above this is an outlier. If we have Q1 minus 1.5, Q3 minus Q1, any value below minus 113 will be a lower outlier. But when we have Q3 plus 3 times Q3 minus Q1, Q3 minus Q1 is known as interquartile range. When Q3 minus Q1 is greater than 949.5, then we will say that any value above this or equal to this will be extreme outlier. Any value which is less than minus 403, which is Q1 minus 3 times Q3 minus Q1, will be extreme lower value. Now, important here is there are few cases like we are from the academic institution. We know that even one student gets placement of 30 lakhs. So we say that that student is an extreme outlier, because of which our average shifted from 8-9 lakhs to 20 lakhs, 5-6 lakhs to 10 lakhs. There, an outlier condition is a business situation. But in my case, the outlier was created because of an error. So we have to understand that in organizations, we want to have higher sales figures. Few sales figure will manage the sales values. We want to have that the result should be wonderful as far as my campus is concerned, my institution is concerned. But at times you will find that there are few manipulations also. So those are error in our business situation. And here in the second condition, we will say that it is an error. So either error or business situation, we have to find out. So this we have seen. This all things we have understood. So using rapid minor also, we have seen these things that we have open, high, low, close, PE and trading value, and missing values are there. What is the type? It is date, polynomial, and what is the minimum value, what is the average, and everything is written. So here also you will find that if we have non-numerical values, then instead of polynomial, it should be a real value. So it means the data that you were having some non-numeric value, Kunal Saab. That's why it was saying polynomial to it. Then, so this says your replace missing value, and we have managed it. So replace and then replace missing value. We have discussed this also. If you have multiple options, then you have to select another replace value. If you have @epsilon, so replace and then expression. And if you have A, B, C, D, E, F, G, H, alphabets, uppercase, lowercase, then you can add another replace value. Otherwise, there will be confusion. First, A, B, C, D should be considered, or special characters, or special characters, then A, B, C, D. Rapid manner does not understand that clearly. So you have to place multiple replaces. Handling missing values, outliers. So we have another data set. You kindly do this exercise at your end. And right. So now we are moving to one model, which is quite interesting. Just a minute. Now, firstly, want to see everybody's. Yes, Kaushik sir.
Sir, that means this extreme outlier in this case is equation 1 and equation 4 on the higher side and the lower side.
Where we have 3 into interquartile range. 3 into Q1 minus 3 into interquartile range, or Q3 plus 3 into interquartile range. Any value above this value, calculated value, and below this calculated value will be an extreme outlier.
Okay.
Are we together?
Yes, sir.
Okay.
Yes, sir. Yes, sir.
So now, who will be supporting me? There are only 5-10 people who respond. The rest people are actually relaxing. It's okay. Life is good. So anyone who now is interested to help me out? Anyone?
Sir, I am there obviously, but I am. It is the repetition, so somebody else should do.
Yes. Rather you, Sonali ma'am, Kunal sahab, they are ready and volunteer earlier also. Anyone who is interested, so that we can continue with our model, which is a very interesting model.
Sir, I'll do it tomorrow, sir.
No, this is not done. But
Sir,
today we are agreed.
This
Today
system
we are agreed.
my system is not working properly today.
Sir,
Okay.
I have a request. Sir, can we have a quick recapitulation of the previous day what we did, because actually I forgot to save that actually. That
Which
has
one?
been deleted.
Yesterday's one.
Yesterday's work.
We will do, sir, tomorrow we will try to do, we will have
Okay,
sufficient time, because tomorrow we will be only doing market basket analysis. So we will have time. We will go through one more time. Anyone? No one. So Apurva sir, I think you are the best person. Sonali ma'am and Kunal Patel sahab have already done. So Apurva sir will be able to do that. Apurva sir, you please, after my request, you keep your system ready. And after my request, you please
Okay. Thank you.
share your screen. So, okay. So, just a minute. I am not taking much of time. Why? Because our organizers, Mule Sahab and Brijesh Sahab, have given limited time to us. So yesterday we were discussing that what all things can be done. So we tried to perform on categorical responses classification tree. We can perform regression tree also on the same model. Only performance will be changed. Performance and model may Gini index, instead of Gini index, you can have the second option, which is your that error. I forgot the name. That error is to be selected. But here in today's case, we are going to a model which do not require an output variable. Here the output variable was attrition. Attrition was the output variable. Here we are not taking any output variable. Only continuous predictors will be selected. And for continuous predictors, we will find that there is a wonderful model which is not only treated as a model, but it is also used for data reduction. The column reduction, the dimension reduction. So it is for principal component analysis is used for two purposes. First purpose is it will be used for reducing the principal component or finding the principal component and reducing the variable. And secondly, it helps in developing a model to understand what are the components which are important. So two different ways this model can be used. Firstly, to know which all modeling techniques are, which all variables are important, and secondly, unnecessary variables can be reduced so that the complexity of our model can be reduced. So we will be working on this modeling technique today. Rather, as per sir's request, we can apply classification tree. Classification tree on another model on the same data set. So let us move to the required analysis. We are not what you say. We are, yes. So we are basically saying that with the help of principal component analysis, we are interested to find out what are the principal component under study. What are the key variables that are making an impact in our study? And it simply calculates eigenvalues, it simply calculates variances, it simply calculates correlations, nothing else. But we don't have to bother those calculations. System will automatically calculate it. So we will simply say that principal component analysis is concerned with explaining the covariance structure of high dimensional data, and a few linear combinations of original component variables are calculated. So I request kindly keep your mic in silent mode. So principal
Professor Bala, can I request you to mute your
covariance
microphone?
or correlation. It uses either covariance or correlation matrix. So in correlation matrix, we know that correlation between two variables between -1 to 1, -1 highly not correlated, highly negatively correlated, and +1 is highly positively correlated. 0 means no correlation exists. And covariance is impact of one variable on another. We know in our previous endeavors and in our academic endeavors, so not going into the detail. So whenever we have the calculation, so we'll simply say that larger eigenvalues denote that the variable should remain in the database and has higher impact as far as other variables are concerned. So in Excel minor, we have covariance and correlation matrix, whereas in the case of rapid minor, we have only one method, which is your covariance method. So you will find that whenever we apply correlation matrix, so the data is already normalized. But whenever we have a covariance method, the data should be first normalized. Why normalization is required? We will again see that. But firstly, whenever we have covariance method, data should be normalized. Wherever we have correlation matrix, there is no need to normalize the data because already the data is normalized by dividing each variable by its standard deviation. So now I request sir to share his screen. Sir.
Yes, sir.
Very simple model for reducing the number of variables so that the dimensionality of the data can be reduced, firstly. Secondly, it can also help in understanding the analysis of the data. So, sir, my request is you first import the data set having name. Just a minute. Bankruptcy. The name of the data set is bankruptcy.
Not here.
On 19th data set, yes. Bankruptcy, yes.
No range is there.
It will come, don't worry.
Oh,
Sir,
okay.
source may take the data. It is showing the first data sheet. Source data. Right, sir. Sir, don't select A and B. So you start from C. Rather, C is also not required. Start from D. Why? Because A is serial number. B will be used for second modeling technique. It is whether the organization is healthy or failed organization. And C is year. So we are not considering year. We are considering from C, no, from D to
B.
colon AA. Right,
Yeah.
sir. So we have not selected these three. Otherwise, if you have selected, then in next stage you have to exclude that. Press next.
Okay.
This is applicable only for numerical continuous data. Right, sir?
Yeah.
So these are
Yeah.
R1, R2, R3, R4. These are nothing but these are the financial ratios. So if you will see, I have opened the Excel sheet just to inform you that these R1, R2, R3. So firstly, whenever we are taking this data set, so the first question that arises is, what are the key components in a data set where the data may be healthy or the data may be failed? So the ratios, so we will say that R1 is cash to current debt ratio, R2 is cash to sales ratio, R3 is cash to asset ratio, R4 is cash to debt ratio, R5 is CFFO to assets ratio, R7 and so on. In your Excel sheets, codes are given. So you can see those codes and later on you can understand what we are discussing. So please press next. These R1,
Yes,
R2, R3 are ratios, and these ratios, okay, local repository, and press finish.
Yeah.
So this is the data set. You can see the data, then you can apply, you can click statistics, you can understand that what is the nature of the data. You will find that there is no missing value, all data sets are real. And you can click visualization also to see, you click visualization. Yes, you can see that R1 is there, then you can select R2. Rather, you can add plots also. Then, so this is your data set. And now please go to the design.
Yes, sir.
When you go to the design, you please drag data to the process. Now, what we are interested in doing, we are creating or we are using principal component as a model, which will help us in doing two things. It will help in telling what are the principal components which are under study. Secondly, it will also help in calculating which are the variables which are not so important, and you can drop those variables for study as well.
Yes, sir.
So please, in the search option, write PCA or principal component.
PCA. This is the principal component analysis.
Yes.
Yeah. Yes.
Please, principal component analysis, drag it. Now connect output of data to input of PCA. And then, because we are interested in principal component, so here, Sir Chandrasekhar sir, here we will use two inputs. Please click connect example to result.
Example to result. Yeah.
Results, and connect PRE, which is principal components, to results. And now run it. So this is your output. This is your outcome. Eigenvalues. So you are saying principal component. What is the principal component one? That we will calculate later on. But which is the first principal component? The first principal component is PC1. And what is the variance? As we know, variance is contribution of this variable on the 100% effect on the study. So we will say that if the variance is 10%, so you will say that that variable has a pi of 10% out of 100%. That variance. Okay.
Yes, sir. Yes.
So if you are saying principal component 1, so it has a proportion of variance 73%. 0.732 is 73%, and principal component cumulative variance is also 73 because it is the first variable. First variable is impacting 73.2%.
Yeah.
What is the principal component 2? PC2 is having a variance of 26% with 0.993, that is 99% cumulative. According to this study, you will say that only two variables are important for our study. Are you with me?
Yes, sir.
Yes, sir.
Because others have very little impact. Yeah.
Yes, sir.
So 1 and 2, and okay, you can take 3 also.
You can, yes, we can, if we want to make 100%, if you are not interested in 100%, if we say 70% variance should be covered, I want to take only those variables that cover 70%. So you will say only principal component 1.
Okay.
Now, sir, you please, so principal number, component number 1, PC1, you don't know the name. Now you want to calculate or find out the name. So you please click eigenvectors, the second option in the left hand side list. Eigenvectors. Yes, sir. Now in eigenvectors, you have these loads in eigenvectors, right? So you have to see vertically PC1. Are you able to see PC1, sir?
PC1, yes, sir.
Yes, this is PC1. Attribute is R1, R2, and principal component is PC1, 2, 3. Now in PC1, you see what is the highest magnitude. And just a minute. When we say what is how health is affected, so you will say you have a positive effect on health when you eat 1 apple a day. So you will say that it has a positive effect, positive impact, positive attitude, positive value. When you say cigarette smoking is also having an impact on the health, but you will say that a negative impact. One has negative impact, one has positive impact. But as far as magnitude is concerned, you will say that both are impacting on the health of an individual. Are you with me?
Yes. Yes, yes.
Similarly, here you will see that under the column PC1, which has the maximum magnitude, and whatever variable has maximum value will be at the left hand side. So please tell me maximum magnitude value. Like first R1 has 0, 0, R2 has 0, 0, and so on.
0.024 R20, sir.
Or R19. R19 is -1.
R19, yeah, -1. Yes,
R19 has a negative impact, but this is the variable having the maximum value. So you will say that principal component 1 is R19, ratio number 19. Are you with me?
Yeah.
Whatever we have done, I will tell you that we have done in something vague manner, but R19 is sales to REC ratio. So sales to REC ratio, sales to REC ratio is R19. So we will say that the biggest component under study is sales to REC ratio, which is R19, and it has a variance of 73%. So it means whatever data we have on the basis of covariance, on the basis of correlation, on the basis of calculating the eigenvector, we will say that the complete, out of the list of the complete variable, the most impactful variable is R19. Are you with me?
Yes, sir, got it.
Yes.
Yes, sir.
Now please click cumulative variance. The next option after eigenvectors. Here you will find that this is the first. You click the first button, square button in the graph on the green line, the first one. Yes. So you click it. So this is the first variable having 73%. Then you have 90, 90, 90, 90, 90, 19, and all 90%. Are you with me?
Yes, sir.
So here you will find that you have calculated which variable is highly impactful. Sir, wait for a while. You keep you unshare your screen and keep your system ready till this place. We have to make necessary changes.
Yes.
Sir, it is -1, which is R19. Now I am sharing. It is not completed. It is not completed. I am sharing my screen. Wait for a while. I am sharing my screen. Wait for a while. I am sharing my screen. Wait for a while. I am sharing my screen. Wait for a while. I am sharing my screen. I am sharing my screen. Right. So here, when we have principal component, we can find out how many components you want to select. If you say I only want top 6 components, so you can write 6. If you want to tell till which variance you want to find the variables, wonderful. You can do that. You can do whatever you want. Here in my slide, one thing you will find which is wonderful, and that is covariance matrix. Please pay attention. I will simply suggest one thing that we were discussing also, that we are using covariance method, and this is the model, and this is the outcome that we have seen. This is similar kind of outcomes. All the values, all the components, or all the variables are near after getting 95%. So it means that whichever are near one is 100%. They are of no use. Unka variance ka matlab hi nahi. They are not impacting. But whether this model is correct, whatever model we have made, whether this model is correct or not. This is some other data set, but please pay attention whether this model is correct. No, this model is not correct. Why? If I will say, let us take a simple example. If I have to make besan ke laddu, and for besan ke laddu we require 10 kgs of besan, 10 kgs or 5 kgs of sugar, and we require only 10 grams of saffron. Now 10 grams of saffron, when is compared with 5 kgs of sugar and 10 kgs of besan, then you will say that automatically 10 kgs of besan will be having more impact. 10 kgs of besan will have more impact, and when we calculate the covariance, when we calculate eigenvalue, automatically besan will have more impact. Then sugar will have impact. So it is wrong to compare or to have a comparison between a sumo pehlwan and a cricket pehlwan. So cricket pehlwan and sumo pehlwan cannot be compared. You want somebody in between that will be that will help us in comparing these two models. So similarly, what is happening then when you have two values which are different in nature? So one column may have higher value, say 10%, 20%, 100%, and second ratio has a value of 0.01, 0.02, 0.03. And when you compare 10%, 15%, 20% values column with 0.01, 0. Automatically the first variable will be more effective as far as the study is concerned. Are you with me?
Yes, sir.
So that is the basic reason. When we use correlation matrix, then every time data is first normalized. They are kept at the same level. But when we use covariance method, then we will find that the normalization is not done, and hence it is important to normalize the data. So my request is kindly, sir, share your screen. Please share your screen.
Yes, sir. Just a minute.
Factors say we make, sir, factors if we make dimension, and in a dimension you can have multiple factors. Here we are not talking about dimension, and then we calculate the factor load. Here we are only calculating covariance matrix and eigenvalues, nothing else. You have to give nomenclature there also as far as factors and then dimensions, and then you have to combine the factors together. So it is a much better and simpler way, and that is pure statistical method. And here we say that it is used primarily for multi-dimensional data in data mining.
Yes.
Rawat sahab, ऐसा लग रहा है मेरे उत्तराखंड के ही रहने वाले हैं. Right, sir. You go to the design.
Yes, sir.
Now, यहाँ पर you will find at the right hand side we have help. Help को please drag down. Right hand side bottom, help, where principal component analysis is.
Yeah.
Drag it. So drag a little bit. Right hand side, drag it so that we can see the contents. Yes, the operator performs a principal component analysis using the covariance matrix. The user can specify the amount of variance to cover in the original data while retaining the best number of principal components. So we are using covariance matrix. So why I am referring this, so that we can understand all the possible options which are available on the screen. Repository, operators, parameters, and above ribbon options also. So when we are saying that covariance matrix is used, it means compulsorily we have to normalize the data. Compulsorily we have to normalize the data, because if we are doing this, so whatever results we are getting is not correct. Why? because every column has different weighted values, and if every column has different weighted values, definitely higher values will have higher importance. Higher values will have higher weightage in the system. So, sir, instead the place where you have searched PCA, kindly search normalize.
Here.
Have you searched normalize? Normalize. Yes, you have the first option, normalize. First, drag and drop and put in between retrieve bankruptcy and PCA. Wonderful, sir. And now nothing is to be done. Normalize all values. Then click normalize.
Yes, it
all
is
values done. PCA. Click PCA. So in normalization process, the normalization is basically done by dividing the data to its standard deviation. Each data values of the column by standard deviation, and we get the normalized series. Okay, sir. Then keep variance, or you can keep 95% variance. Rather, it is not making much impact. Or you can keep variance, dimension reduction. Please click keep variance. Click that one. You can have keep variables also, or fixed number of variables. If you will say fixed number of variables, so it will give you how many variables: 5 variables, 2 variables, 10 variables, or all variables. So you keep none. You keep none. Neither variance nor yes. Now run it. Now suggest what has happened. And the principal component 1 has a standard deviation of 2.9 and proportion of variance is 37. So out of 100%, principal component 1 has covered 37% of the study. Principal component 2 is 13% and cumulative is 50%. Principal component 3 is 11% and cumulative is 61. So if I say that tell me how many variables are there till 83%, so you will say that principal component till principal component 6. Principal component 6, we are covering 86% of our, or 83% of our.
83.
Are you with me?
Yes, sir.
Now, if you go to eigenvectors, yes, sir. Kaushik, sir.
Sir, this cumulative variance, like, is there any standard proportion like 70% or above or 80% of above?
It is up to you, sir. What has happened? You will tell your employees that I want to know that what are the key 3 attributes of success of any student in placements. When you say 3 attributes, so irrespective of variance, you will say these are the 3 attributes. You will say that no, what are the variables that are covering 70% of importance for my placements? Then you will say that 70% mean these 10-15 attributes are there. So you will tell these are the attributes.
And like you mentioned 3, so earlier we took all, so number of factors, then you have to put 3 there earlier.
Yes. No, even though you put all, our study will calculate only first 3, principal component 1, 2, 3, and therefore if you will say 3, so only 3. But I think in the free version of this, irrespective what you are doing, it is giving all cumulative variances and it is giving you all variables. Hardly matters, because if you are selecting 3, so it will give you top 3. If you are not selecting top 3, so all 10, 15 will be selected. You have to find that these are the 3 variables. That's it.
Yeah. Thank you.
Okay, so go to the next one, eigenvectors. So now eigenvectors, see the principal component 1. So now all values, irrespective of weights, have the common weight. And then those common weights will help us in finding the principal component. So please tell me which variable has the highest magnitude, irrespective of positive or negative.
You are looking for
highest magnitude value.
R24, R23.
And if, please pay attention, if you have a variable which has 2 variables has very close values to second or third decimal place, you can consider both.
So there are so many key variables.
Sir, which is the one?
R23.
R23.
R15.
Oh, there is a phone call.
(15, 16, 17, 14).
Yes. So R23. So you will say that now R23 will be the variable which is treated as the principal component. And what is R23? W, working capital financial by asset. So R23 is the ratio between WCFO / assets. So you will say that the most important variable or the principal component of this study is R23 and R23. We don't know R23. When we talk to our colleagues, our bosses, our financial experts, so we will say that WCFO divided by assets are the most important variable that are deciding whether my organization will be failing or will be a healthy or successful organization. And it is covering, sir, please go to eigenvalues. It is covering how much variance? It is covering 50. So whenever an organization, whenever we decide that whether the organization will be healthy or not, so we will say that on the basis of R23, which is WCFO to asset ratio, should be considered because it is making an impact of 37%, not 50%, sorry, 37%.
But sir, here in this case, if I go to the eigenvector, there is so many values which is near about this is R23.
Sir, R20 because the ratios are in that range only. Yeah. If you are saying that R23 is 0.29, if you have something 0.28, something 0.286, something 0.2888, you can consider that also.
Oh, okay.
0.286. So R15 combined with R23 will be the principal component.
Principal component. Okay.
It should be very close to each other. Okay.
Okay.
Go to cumulative variance. So you can see that how the variance is. So until PC8. So here you will find that now it is 37, then 50, then 60, then 70, then 76, then 81, then 85, then 91, then it is gradually increasing. Last time only 2 variables were required to have a 90% of variance.
Yeah.
Here you will find that we require at least how many variables? You require at least 8 variables to reach to the cumulative variance of 90%.
Yes, 8 variables.
8 variables, right?
Yes.
Okay. So this is your principal component, and it's very simple method, very effective method for data mining and business analytics to find the important variables which are for the study that is under consideration, and what are the variables that should be considered and what are the variables which are not to be considered if we want to reduce. Suppose we have 1000 variables. So if we see that 100 variables are impactful and having an impact of 95% variance, then the rest can be removed because 95% will be considered, will be covered using this data set. Now, after this, we have to perform a very simple thing. Apurva ji, Sonali ji, Krunal ji, Joshi ji, anyone who want to be volunteer.
So I have one question.
Yes.
So where this PCA new component are being added? I mean, is it in data sets? The new component which has been generated?
Where you tell me?
I am asking you where it is generated. I mean, the new component that we have identified, where it is.
Which component? PC? Should we go to design?
No, I'm talking about, see, we have identified that this is a new component. PCA1 is one component which has P29 as a major.
Okay. Sir,
so if I want to run, my question is,
vectors.
Yeah. So my question is, if I want to run a regression based on this PCA, so where this PCA new component which has been generated, where it is, I mean, in the data file?
No, you have to interpret here only, sir.
So I cannot make use of this file to run.
Sir, you can directly apply multiple linear regression on this data set, but our purpose is different. In multiple linear regression, we have a response variable and we have predictors. Here we don't have response variables. On the basis of multiple correlation, multiple regression, and calculating eigenvalues. Here we are calculating covariance. We are calculating the eigenvalues, and on the basis of that, we are calculating the cumulative variance and scores. So there is no response variables. On the basis of the data, calculating the covariance, we are trying to find out which variable is more impactful. But if you want to calculate that which variable is impactful, you have to first interpret this data series. Patel sir?
Yeah, I got your point, sir.
And if you want to apply multiple linear regression, then we will use this value in different way. I request if Purvaji is sharing well and good, or if Sonali ma'am or Kunal Patel sir. Sonali ma'am, yesterday you have not completed that modeling. So we will apply the same modeling, that is regression tree, classification tree on this data set. So my request is kindly share your screen.
Okay.
So I am stopping myself.
Who is sharing?
I am sharing, sir.
Please.
I take a new file, right, sir?
Yes. I'll tell you have to. Ma'am, you just a minute. You open a new process first.
Yeah. So I'm saving the earlier one. Oh. Blank process. Yes, sir.
You take, ma'am, bankruptcy T data.
Bankruptcy T data, yes, sir. Done, sir.
Then, after selecting bankruptcy T data, select the role. Set role. Yesterday you were not able to do. Apurva ji, this will be revision also for the yesterday's work.
So role, where do I go?
Rawat Saab, not possible. It is specifically for this type of data. Set role.
So where do I?
Set role.
Set role. Okay.
When we have a matrix, or when we have a column, or we have continuous data set in metric form, then only we will try to find out. Ma'am, move it to the lower portion of bankruptcy.
Okay.
Yes, ma'am. Connect output to set role. So we are using the same data set, and in the data set, basically, if you see, we have first column as number, record number. Second column is whether the organization is healthy or not. If we have D as 0, so we will write it as a failed firm. And if it is D as 1, we will write it as a healthy firm. Right? So, I think before doing this classification, we can do one more thing. Sorry.
Yes, sir.
You please uncheck all this. You delete this process. So you delete everything. We are not taking. You go to the Excel sheet, ma'am. You minimize this and go to the Excel sheet.
Bankruptcy one, sir.
Yes, ma'am.
I could not find it. Yes, sir. Can you all see my file, sir?
No, we are not able to see your files, but what you can do, you can add one column between C and B.
Okay.
And write in at all places where we have 0, fail, F-A-I-L, and
the screen has not shared actually.
No. So actually, I am also not able to see. Between A and B, you are saying, sir?
Yes, between B and C.
Okay.
Professor Sonali, can you please reshare your screen?
Yeah. So I'll do that.
Sir, it is which sheet? Data sheet or code sheet?
It is
Bankruptcy.
data.
Data sheet. Okay.
So this one, is this the file bankruptcy?
Yes. No, ma'am. Next one. Data sheet.
Sorry.
No, ma'am, I think the same Excel, but next
Same
sheet.
Excel, but sheet is different.
Yeah.
Okay.
It was the correct one.
Worksheet number 3. We are not moving to sheet number 3, the same one.
So today we had air pass, cleaning price data, and gold NSE.
No. The same sheet.
Bankruptcy.
This sheet only, bankruptcy. This is the workbook. This workbook.
Okay.
You open this workbook, ma'am.
Okay,
The
just
same
let me.
workbook, bankruptcy.
Okay. Let me open, sir.
Yeah,
Yeah,
this,
only 2 minutes left.
Source, codes, and data. Okay. The data one you want, sir?
Yes.
Yes, ma'am.
Okay. Give me a moment. Sorry. Extremely sorry. Is it okay, sir?
Ma'am, please share your screen.
I have, sir.
Now it is.
Yes, sir.
Yeah.
Yes.
Ma'am, between B and C column,
Yes, sir.
insert a column.
Yes, sir.
Now here, write health. Title will be health.
Sorry,
We
sir.
can do it in rapid minor also, but because of time limitations, we cannot do. There is one option known as turbo preparation. We can do everything there. So, ma'am, health, right? Health,
Health. Okay.
right, ma'am. And now at all zeros, so 0 should be replaced by fail, and 1 will be replaced by healthy.
So I do it as replace.
You can do so. अगर आप replace करते हैं तो then
Replace all 0 with.
ma'am, then every 0 will be replaced in the data also.
Oh,
You
yeah.
only want that for B.
Okay.
For B column. For B
Okay.
column, sir.
Yes, sir.
Yeah.
So I replace 0 with.
Equal to, ma'am, at
0 with failed.
C1, right? C1, yes, below health, equal to if left bracket B2 equal to 0, comma, within double quotes, fail, comma, close, comma, ma'am, okay, that is, no. First you close that code, comma, healthy, bracket close, enter. Ma'am, drag this formula.
Yeah.
Okay, ma'am.
Okay. Why did it come as name, the last one? Anyway, it's healthy then. Anyway, I'll make
It is healthy, but it is not accepting the formula.
Yeah. So I'll keep it. I'll make it healthy to
Yes.
save time.
Right.
No, ma'am. Actually, go to formula, first one. The healthy should be within double quote.
Oh, you have not written codes within
Yeah.
inverted
Okay.
commas. It should come double quotes.
ठीक है. I'll make it this way. Is it okay, sir? It serves our purpose.
Okay.
Shortcut.
Okay. ठीक है,
To
done,
save
done,
time.
done.
Yeah.
ठीक है. No issues. Now, ma'am, save this file
Yes, sir.
and close it.
Yes, sir.
Now go to the original rapid minor. We have only 2 minutes. It is already 11:32.
I'll stop sharing this.
You share your rapid minor screen.
Yeah.
We will not take more than 2 minutes, Brijesh sir. No, we will not take more than 2 minutes. In case anyone wish to provide any inputs on today's session for improvement for tomorrow's session, please note it, please write on the chat box, so that in the meantime we will be preparing ourselves.
Yes.
Okay. Import data. Okay, that data only, but because it is changed, so we have to take it again. Or we have to refresh the data.
Yeah, this one. The Excel sheet.
Yes. Next. Okay, source में source go to source
Data.
Source में data. Right.
Hmm.
Cell range, take range from C colon AB. C colon AB.
Next.
Yes. Next. Okay.
C colon AB. Okay.
C colon AB. Yes. Next. Yes, ma'am. Wonderful. Now retrieve this data on the process file. Go to design.
Design. Yeah.
This data.
Yeah. This file, bankruptcy. This file.
This is the file, huh?
Yes, sir. Yes, sir.
Recently updated.
Yes, sir.
You please check which is the recently updated.
This is the one, sir.
Are you sure? You
Yeah.
see, you drag down at the lower portion and see what is the time of dragging it. No.
Yes, sir. It is 11:30 something.
Okay,
Yes, sir.
fine.
Yeah.
Okay. Ma'am, now go to the role. We want to find out what is the role. So remember, here with the help of decision tree, classification tree, we are interested to know what type of organizations fail on the basis of financial ratios, or what type of organization, what financial ratios contributes in the health of the organization. So we want health as the set role attribute. So select set role.
Yeah, sorry. Yeah.
Delete it, no issues. Connect input of bankruptcy to set roles, and drag set role below bankruptcy.
Okay.
Click set roles and go to the variable. Enter variable attribute name. No.
Sorry.
In the parameters, right hand side.
Here.
Parameters. Go to. Madam, click set roles first.
Okay. Yes, sir.
Now variable.
Health.
Health.
Yes.
We want to see, check health. Target variable will be label.
Label. Yes, sir.
Now this work is done. Now the next one is split data. Search split data on all studio variables.
Split data.
Yes.
I drag it.
Below set roles.
Okay.
Yes. Connect example of set data. So we have retrieved the data, defined what is the output variable. So Rawat sir, here we have an output variable. Kunal Sahab, here we have an output variable. That's why we are making it. In principal component analysis, there was no output response dependent variable. Okay. Now the split data. Go to edit enumeration on the parameter side, right hand side.
Here. Yes, sir.
In parameters, click it. Add entry. 60%. So we have to write 0.6. So this time we are taking 0.6. 0.6. So we are taking 60-40 last time. 70-30 we have taken. Then add entry. Add entry 0.40. So two partitioning we are doing. One for the training and one for the validation. Okay.
Right, sir. Okay.
Then add decision tree. Search decision tree where you have searched split data.
This one?
Third one, yes. Take it to the top next to bankruptcy, right hand side. Yes.
Yes, sir.
Connect split data partition 1 to the
this one, sir, right?
Decision tree, yes. And now take apply model as another variable, another operator.
So here.
Yes,
This
first one.
Yes.
First
And
one, yes. Drag it below decision tree.
yes, sir.
Yes.
Hmm.
Now, the next stage is the model of decision tree will be connected to input model of apply model.
Mm-hmm. What do I connect, sir?
Yes, model of
Model.
decision tree, output
Oh.
variable model of decision will be connected to model of apply.
Yes.
Wonderful. And second partition of split data will be connected to the universal of apply model.
Okay.
Yes.
Correct.
Wonderful. Wonderful.
Mhm. Yes, sir.
Then search for performance classification. There will be multiple performances, but we are yes, the first one.
First one. Yes, sir.
Yes, connect it, drag it in front of decision tree.
Yes, sir.
We are making verticals. Why? Because we are performing data related work, model related work, and performance. That's why three verticals we are making.
Right,
Three
sir.
columns we are making. Okay. Then connect apply model label to performance label. Connect model to output variable.
Where, sir?
Yes, yes. Output is RES. RES is result.
Sorry, sir. Here. Okay. Yeah.
Yes. And performance to result.
This one also. To the other result?
Yes. No, 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 no.
Same.
Yes, this one. The other second result. Yes.
Yeah.
Yes. Move apply model to a little bit lower portion so that we can
Yes,
see
sir.
what are the links to the
Yes.
right hand side, a little bit righter. Yeah, yeah. Right. If you don't want these cross between performance and output and apply model output, you can redo it and performance to the first output and this, no worries on that.
Yes. Yes.
Now go to decision tree. Now we have done everything. We have to simply tune our model. So click decision tree.
Yes, sir. Done.
Gain ratio, no, we will select Gini index,
Okay.
right? Then maximum depth we are taking 5. You can increase later on also. 5
Yes,
will
sir.
be visible or 3 will be visible, right? Then
Yes,
go
sir.
to apply model, go to performance. Click
Again here?
performance operator. No, click performance operator. Our model is ready, ma'am. Performance operator on the process.
Here.
Yes. And then click classification error. The second one.
Yeah, it's all.
Now run the model. Okay, ma'am.
Yes, sir.
So it is 70% correct. Now go to decision tree. Tab decision tree tab is visible, ma'am. No, no, no. Here.
Sorry,
in
sorry.
the tab.
Yeah.
Result tabs,
Yes.
decision tree.
Yes, sir.
So this is the tab.
Okay.
If R9 is less than 1.925 and R8 is greater than 11.070, all the organizations are healthy. So if you want to ensure that the organization should be healthy, then your R9 and R8 ratio should be managed between these two. But if you are saying R9 is less than 1.925, R8 is less than equal to 11.070, and R21 is less than equal to 1.755, then most of the organizations are
Failing.
So you have to avoid organizations to fail, you have to manage R9, R8, R21, then the organization will be less fail. So the answer to Rawat Sahab and answer to Patel Sahab is this only. When we have output variable, we know that we want to understand whether the organizations are healthy or fail. So we can apply such kind of predictive modeling. And when we have to understand what are the key attributes that are contributed, we will be using such kind of modeling, which is your regression or classification tree.
What we have done in split data?
Pardon, sir?
In split data, what we have done, basically given some ratio.
These are, sir,
actually, I
in
could
your
not
Excel
follow,
sheet,
actually.
you will find that ratios are written. So you please go through that Excel sheet, data, code, and source. So data will be, these all are F1, F2 are financial ratios. We have discussed in principal component also that these are financial ratios. Okay, we complete here our session. Sorry, it is an extended 7-8 minute session.
Thank you very much for this elaborative and exhaustive practical session. And I think all professors must have enjoyed it. And now our next guest is already there. So,
should I leave?
Yes, sir, you may
Okay.
leave.
Namaskar. Thank you. Tomorrow again we will
Thank
meet.
you, sir.
Tomorrow again we will
Thank you,
meet.
sir.
Thank you much. Thank you so much, sir. Yes. So, guests, our next guest participant is here. Can I request everyone to mute your microphone so that I can? So, our next guest for the next session is Dr. Sachin Deshmukh. So, Dr. Sachin Deshmukh possesses a high degree of affinity towards the use of quantitative techniques in the area of marketing. He is currently a director of Vivekananda Education Society's business schools and also a professor of marketing analytics, statistics, data analytics, and artificial intelligence machine learning. He is trained in Python and SAS platforms and possesses skills in machine learning and data visualization. Dr. Sachin Deshmukh is currently working with students on various data analytics projects and drone technologies. He is also guiding students on startups ideas and is instrumental in rolling out startups in the field of data analytics and artificial intelligence. With these words, I will invite Dr. Sachin Deshmukh to take over and start his.
Yeah, thank you, Dr. Pranjal. I hope I am audible.
Yes, sir, very much.
Yeah, thank you very much. Good morning to all of you. I think we are 15 minutes running late. What we are doing today is, you people are just staying back and relaxing. It is the story time. Whatever I will be doing today will be on Python, and it won't be easy for all of us to download Python today, download the libraries, and get something for practice. So instead, I thought that these 120 minutes I shall demonstrate the strength of machine learning. We will pick up one algorithm, and then I shall try to demonstrate that algorithm through Python. Maybe the first few parts I will be doing it on the Python editor and executing the code, but later on maybe I will just be using my slides. Okay, if at all you have any questions, you are most welcome. You can put your questions at the end of the session. Now, the reason for VES to conduct this session and link it to strategy is that if we are able to motivate 20% of the participants today, motivate to take up analytics and link it to strategy, then I think we will feel that our objective has been achieved. But for the last 15 minutes, I was just listening to Dr. Meher and a few of the participants trying to do something on RapidMiner. I think that was an excellent exercise, but unfortunately we are unable to do that on the Python platform. So let me begin. I have in fact two programs. One program is on logistic regression, wherein I shall be picking up a data set called Titanic. The reason for this is Titanic, I think most of you might have watched the movie. And then we shall try to correlate, how the storyboard of Titanic movie, was created from this, the analysis of this data set. In fact, I wanted to take logistic regression, by using some industry database. But unfortunately, we are into non-disclosure agreements with the companies. For example, we have used logistic regression for customer attrition for a bank. But we can't give out that data, and therefore we are restricted in using that, and that is the reason why we are using the Titanic data set. The second data set, if time permits us, will be on housing. So it is a real estate problem, and we are picking up the data from USA, especially the county of California. So let us begin with the first one, the logistic regression. I'm sharing my slide. I hope my slide is visible.
Yes, sir.
Okay, thank you. Right, so this logistic regression will be done on the Python platform, and we are using a machine learning algorithm for producing some analytical results. So basically, I think by this time everyone might be knowing about the different types of analytics that is being used by the industry, and I won't be getting into this much. So the first one is descriptive analytics, where you will be making use of something like descriptive statistics and data visualization to understand the behavior of some individual variables in the data set. Then we have predictive analytics, through which the companies try to make predictions and try and understand the future behavior of the variables. And the third one is prescriptive analytics, where we make use of a combination of machine learning, business rules, artificial intelligence, and various algorithms, to find out the best possible actions to optimize the business practices. And perhaps, this prescriptive analytics would be more linked to the strategy formulation of a company. Before we get down to logistic regression, which is of course one of the type of regression, there are about 16 different types of regression. I have not listed all of them because then that would create confusion. Okay, one more thing I would like to clarify is that I'll be talking in a language which can be understood by a layman. Layman in the sense those people who are not exposed to any analytical background. So I try to simplify my lecture as much as possible so that even the layman can understand what I'm talking. So the basic regressions that are quite famous in the industry are the linear regression, logistic regression, quantile regression, ridge regression, lasso, that is known as list absolute shrinkage and selection operator, elastic net regression, and the principal component regression. Like this, you have total 16 different types of regression models. Now, basically, what is machine learning? I think this slide should speak about the definition of machine learning. You try to train your computer on some machine learning algorithm. Now, this algorithm will then evaluate the data. Okay, if it finds errors, if the evaluation has some errors, then that will be fed back to the problem, and this iteration will go on. Every time the algorithm is executed, there will be an improvement in the output of the program. So you are trying to train computers on the data with the help of a machine learning algorithm, so that you get accuracy highest as possible. So machine learning is training your computer on data with the help of some machine learning algorithms. Now, the basic types of machine learning algorithms are classified into 4: supervised learning, unsupervised learning, semi-supervised learning, and reinforcement learning. Again, now, these things will turn into chapters, and we do not find much time to go through all this. Just for your information, I am naming these different types of machine learning algorithms. And then, some of the famous machine learning algorithms are linear regression, logistic regression, decision tree. I think in the previous session you did some problem solving with the help of this particular algorithm on rapid miner. We have something called as SVM algorithm, that stands for support vector machine. Then you have naive Bayes algorithm, K nearest neighborhood algorithm, K means algorithm, random forest, dimensionality reduction, and finally something known as gradient boosting algorithm and ADA boosting algorithms. So even if you are able to master 3 or 4 algorithms, I think you can make a very nice career in analytics. Now, as far as the Python environment is concerned, the latest Python version, now this is an open source. Each one of you can download Python from python.org, and the latest version is 3.10.1. But I would suggest that the ideal platform is version 3.7. It is almost bug free, and most of the time, when I want to use machine learning algorithms, I prefer this particular version. Now, once you have done with your installation of Python on your computers, automatically you will get its editor, which is known as IDLE, that is Integrated Development and Learning Environment. So this particular program editor comes by default once you download the Python program. Apart from that, you have other program editors which are quite famous. Like you have something known as PyCharm, Visual Studio Code, Sublime Text, Vim, Atom, Jupyter Notebook. Now this is the one which is mostly preferred by the industry. You have something called as Eclipse, PyDev, Lyclipse. You have Spider. Spider also is one of the most famous of editors used by the industry. You have Thorny, and now you have Google Colab. So if you're not interested in storing all your programs on your computer, you can make use of this Google Colab, because it is cloud-based programming environment. So it is up to you which one you would like to use. And if you ask me what should you prefer, and then that is Jupyter Notebook. Okay. As far as teaching my student is concerned, I make use of IDLE, Integrated Development and Learning Environment. Okay.
Sorry to interrupt you, sir. Professor Apurva, can I request you to switch off your camera? Professor, yeah, thank you very much.
Okay.
Sorry, sir, you can carry.
Yeah. Now, it is just not possible, to download Python and start working on it. Even though you can, develop any program and get that executed on Python, developing complex program and executing them on Python alone would be a tedious job. So what we can do is we can install some ready-made libraries. So we have something called as pandas. We have something called as NumPy, Matplotlib, SciPy, PATSy, Stats Model, Seaborn, XLRD, Scikit-learn, TensorFlow, Keras, and LE5. Okay, so if you want to make a start, then at least you should have pandas, NumPy, Matplotlib. Okay, and if you want to work on statistical models, then PATSy is a good option, SciPy is a good option, Stats Model is a good option, Seaborn also is a good option. And if you want to work on machine learning algorithm, this should be your choice, the Scikit-learn platform, or rather the library. Then apart from that, you have something called as TensorFlow and Keras, wherein you make use of advanced concept like pipelines. And those pipelines concept helps you to execute complex programs quite efficiently. So if at all you want to give a start to your Python career, then at least these three, Stat Models and Seaborn, are a must for downloading. Any questions so far? Any questions? Okay. No, sir. I already mentioned that we will be working on logistic regression today. The objective of this particular exercise is define the concept of logistic regression, fit a binary regression model using a logistic regression task, describe the standard output, and finally try and interpret the odds ratios. Okay. So has anybody worked on regression modeling? Has anybody worked on regression modeling? Most of you might have done your PhDs. You have touched statistics at some or the other stage in your PhD. So can anybody tell me the equation of regression model with one dependent and one independent variable? Anybody?
Y is equal to alpha plus beta x.
Okay. So nobody has any idea about
Y
regression
is equal
modeling.
to alpha plus beta x.
Kunal, we are unable to hear you. I think you're trying to speak out, but we can't hear you.
Y is equal to alpha plus beta x.
Sorry?
Y is equal to alpha plus beta.
No, I'm sorry, I'm unable to hear you. Okay, so if anybody else want to try?
Sir, Kunal sir was saying alpha plus beta.
Fine. So if you don't have much idea about regression modeling, then it may be perhaps difficult for you to understand the concept of regression modeling. Now,
Sachin
this
sir,
is
you
the
can hear us?
regression model
Sachin sir, you
with
can hear us?
one independent variable and one dependent variable. So the variable to the left of the equal to sign yi is the dependent variable, and the variable to the right of the equal to sign x is the independent variable. We call beta naught and beta 1 as the parameters of the model. Now, if you just try to avoid this epsilon sign at the last, you are left with y is equal to beta naught plus beta 1 x. Now, if you are trying to use this as your model, then it won't be considered as a statistical model. Unless and until there is some randomness present in your model, you cannot make use of that model in the world of statistics. And that is the reason why we are trying to make use of epsilon, which induces randomness in your model. So merely talking about y is equal to beta naught plus beta 1 x is a mathematical model, and the name linear regression model comes from this, because this y is equal to beta naught plus beta 1 x represents a straight line on a graph paper. Okay, the moment you add a random variable called epsilon, then it becomes a statistical model. So a complete statistical model, which you name as regression model, is y is equal to beta naught plus beta 1 x xi plus epsilon. Now, this model alone, the explanation of this model alone would take me a lecture of, require a lecture of 60 minutes. So for the time being, you have to just remember that this is a regression model, and based upon this regression model, you can extract different types of models, regression models. Now, the next concept is the logistic regression model. Now, you will have to understand that for which data you can develop a regression model, and for which data you can use a logistic regression model. So not all data you can use the linear regression model. Why? Now, there are some reasons for us not to use the linear regression concept, okay, in developing a statistical model for the data. For example, y is equal to beta naught plus beta 1 x plus epsilon. In this regression model, y is a continuous variable. So the moment you have a continuous variable in your data set, continuous dependent variable in your data set, you can always apply the concept of linear regression. Okay, but what if the dependent variable y is not a continuous variable? Then you have a problem on hand. You cannot apply the linear regression method. Any questions till this point of time? Okay, so y should be a continuous variable in case you want to develop a linear regression, and if y is not a continuous variable, you cannot make use of a regression model, linear regression model. So now the question is when to make use of the logistic regression concept. The moment you find that y is a categorical variable, okay, then you make use of logistic regression. And let me tell you that this logistic regression model is quite famous in the industry just because it gives you quick answers. For example, when we did the logistic regression model for customer attrition in a bank, there was a time, I don't want to name the bank. There was a time when the bank was really worried that their customers would leave the bank and would go elsewhere. So we were told to develop a model and we were told to calculate the probabilities, like in the first 3 months who all customers would leave the bank and go elsewhere. In the next 6 months, who are the customers who may leave the bank and go elsewhere. So like this, we were given buckets of 3 months, 6 months, and 1 year, and accordingly probabilities were calculated to find which all customers would leave the bank. So that was not enough. Okay, so this was the part of analytics. Then came the part of marketing. So the moment we found that these many customers would leave the bank in the near future, okay, we try to dent into the problems that were faced or the negative aspects that they had in their minds about the bank. So accordingly, marketing campaigns were designed and they were shot on their devices like the mobile phones or the computers. Okay, so this is how you try to make use of logistic regression and link it with the marketing. You might be also knowing the story about Barack Obama. Has anyone heard about the success of Barack Obama, especially in the second term of his office? Anybody? Okay. So this is the story of Obama's success as a president second time. So what happened is he hired a team of analytics, okay, 6 months, I think 1 year before the elections, and they were given a task like finding out the probability of Obama's winning. Okay, so what they did was they divided the citizens of America into 3 categories. One category was fully supporting Obama. Second category was not at all supporting Obama, and the third category was the dicey citizens who were not able to arrive at a decision whether to vote for Obama or not to vote for Obama. So under the circumstance, the team they thought of concentrating, not to concentrate on the segment which was for Obama. They thought not to concentrate on the segment which was totally against Obama, because kitna bhi sar fold lo unke upar, they were not to get converted, and it was just not possible to bring them on Obama's side. So they discarded these 2 segments and then they concentrated on that dicey segment, wherein the citizens were not in a position to decide Obama ko vote dena hai ya nahi dena hai. And then further, the team dented into their psychology to find out what were their problems, why they were dicey. And accordingly, again, the campaigns were developed and shot on their devices. And this is how Obama was successful in getting his second 5 years office. Now, coming back to logistic regression, why we cannot apply linear regression when the dependent variable y is categorical? I hope people know the meaning of categorical variables. Anybody? What is a categorical variable? I just can't find responses. Let the answer be wrong, but you have to give it a try.
So yes, no.
Hello. Yeah, anybody? Hello, am I audible? Ranjil sir?
Yes, sir. You are audible.
Okay. Okay. So what is a categorical variable? Anybody?
Sir, gender, sir.
Sorry?
Gender?
Yes, gender can be a categorical variable. Yes.
Yes,
married,
or no questions? Sir?
Yes or no questions, married, unmarried, whether a customer would buy a product on the counter or may not buy the product on the counter. Yes.
Basically, when it is a dichotomous, any
yes,
reply is
you
dichotomous.
can, yes, you can call that also as a dichotomous variable. And it is not necessary that it should be a dichotomous variable. It can have more than more than 2 levels. Okay, so it can be having more categories. Okay, but then we will be sticking to the binary categorical variable or dichotomous categorical variable to make things very simple. So I was trying to tell you that if your dependent variable y is not a continuous variable, you have to stick to logistic regression. So this is the example. This is the example of logistic regression model. So you have 3 independent variables giving the inputs. Okay, you construct the logistic regression model in order to find whether your employees are happy or sad with the environment in your organization. Now in this case, theta1, theta2 and theta3 are called as the weights. Okay, and these weights will be calculated by the machine learning algorithm. Okay, so like somebody said that it can be a dichotomous or a binary variable. Not necessarily that it is always a dichotomous variable. It can have more than 2 levels in the variable. Okay, so in this case, we shall be trying to work on the Titanic data set. The best part of making use of Python and the Python libraries is that you don't have to get into all this nitty-gritty of the mathematical side. Okay, you must have some knowledge of basic statistics, and you must know how to interpret your result. Your life becomes very simple, in analytics. So with Python libraries, giving you that chance of not to dent into the nitty-gritty of mathematical part, okay, you must then be in a position to interpret the final results that you are arriving at. So I won't be doing much because this is something which my students will go through, but you can avoid this. You don't have to get into this mathematical part. Okay, now what happens in fact is in linear regression model you get a straight line, but if I try to fit a straight line to the data where the dependent variable is categorical, then that straight line will be meaningless. So if you look into the left hand side of the graph, the linear regression part, you are trying to fit a straight line, but you will find that there are only 2 categories of the data under the dependent variable. So either the level will be at 0 or the level will be at 1. So under the circumstance, it is not possible for us to fit a straight line, and that is the reason why we cannot use regression model if your y variable is categorical. Now after deriving all these mathematical equations and arriving at a final expression, this final expression is represented in the S-shaped curve on a graph paper, and this S-shaped curve is known as a sigmoidal model or a sigmoid function. So if you are having y as a categorical variable, you are bound to get this sigmoidal shape on the graph paper rather than getting a straight line. Now let us try to work on the Titanic data set now. Okay, now this Titanic data set, if I am not mistaken, at the time when Titanic met with an accident on April 13, 1913, okay, there were about 2,203 passengers on board. Okay, so I have a data set wherein we have the information of 891 passengers. Okay, and we are trying to fit a regression model for this particular data set. Now, logistic regression model for this particular data set. Now, the question is, why do we need a logistic regression? The reason is, I would like to know whether a particular passenger, who was on the ship at the time of accident survived the accident or was dead in the accident. He died in the accident or she died in the accident. So under the circumstance, I am compelled to make use of the logistic regression model. Okay, so my dependent variable y is a categorical variable where I will be trying to find out whether the passenger survived the accident or he died in the accident. Now, this is for 891 passengers data. Now, when I fit this logistic regression model, I can use this as a predictive model. So the moment I get information of some more passengers, then I can apply this logistic regression model to find out whether that passenger survived the accident or he died in the accident. So that is how you try to make use of the logistic regression model for predictions. Right. Now, if I want to, basically the data is on an Excel sheet. Okay, I will just try to show you the data. Okay, so you can see the data is on the Excel sheet, and if I scroll down, okay, it will show you about data of 891 passengers. Okay, this is 891 passengers. So what we are trying to do is we are trying to take this particular data sheet on the Python platform. Okay, so data in some other format like Excel or any other format or a CSV file, comma separated variable file. You cannot, start analyzing the data in this format straight away on the Python platform. So what you have to do is you have to pull this data on the Python platform. So either you create an array using the NumPy library, or you can create a data frame using the pandas library. So panda in fact stands, PN stands for panel and DA stands for data. So if at all you want to convert these such data in the other format and bring it to the Python platform, you can make use of this pandas and convert it into something called as a data frame. So if you look at the slide, I have given the first part of the Python program wherein you are trying to convert the Excel worksheet into a data frame. Okay, so here basically we are trying to import these libraries. Of course, these libraries must be present on your computers, without which you cannot make use of. You have to install them on your computers. So I will be making use of NumPy library, pandas, matplotlib. Matplotlib is the one which will help you in graphics. It is quite famous for graphics. Cmon is quite famous for statistics. Now with this particular part of the program, I'm going to convert the CSV file. Even though it is seen as an Excel file, it is a CSV file, comma separated variable file, which I will be pulling on the Python platform. So I will show the execution of the program. Okay, I hope you can. Oh, it's difficult. Can you see the slide? Hello.
No, sir, we cannot see the slide. It is all blank.
Okay.
Black color. Yeah. Yeah. Now we can see.
Okay. So can you see the program editor now?
Yes, sir. I think there is some lag, sir.
Okay. Okay. Now this is called as the program editor of the Python platform, and I am using the original one that comes with the Python installation. Okay, I told you can make use of any other program editor that are freely available on the internet. Now what I'm doing is I'm going to write some code over here and get this executed. Okay, so in this code what I'm trying to do is convert the CSV file into a data frame, pandas data frame, and I'm going to just display some of the rows on the Python platform. Okay, so I will execute this code. It is taking some time. Okay, I hope you can see the output. Yes, sir. Right. Now, in this case, you will find that the CSV data is now being pulled onto the Python platform. So you can see the first 5 records of the data set, and finally you can just read the variables that are present in the data set. It starts with passenger ID, survived, P class, so on and so forth. Now let us try to have a look at the variables. Okay, now the first variable in the data set is passenger ID, and that is just an identifier of every passenger on the ship. And then you have survived, which is a binary identifier, wherein the value of 1 will represent the passenger survived the accident, and 0 represents passenger was dead in the accident. Then you have the next one called P class, which speaks about the ticket they were holding. Was it first class, second class, or the third class? Then you have the name of the passenger. Then you have sex, male or female, age in years. Then you have a variable called as SIBSP, that is the number of siblings and spouses aboard the ship. You have PARCH, that is the number of parents and children aboard the ship. You have the ticket number. You have the fare paid by each passenger. You have the cabin number of the passengers. And then you have a variable called as embarked, which speaks about the port on which the passenger embarked the ship. So there were 3 ports covered by that time the ship met the accident. The first one was Cherbourg. And we are picking up the first letter as the representative. Then you have Queenstown and Southampton. So port visited these 3. So the ship visited these 3 ports, and the passengers, they boarded the ship from these 3 ports. Now, the very first thing you try to do in machine learning is, the descriptive part. Okay. Now in descriptive part, I would like to know the behavior of the variables. So how we proceed? The very first thing is, trying to go for data visualization. I would like to know, whether the number of survivors was more than the number of dead people. And from this particular slide, you can see that you have a bigger bar for 0 and the bar for 1 is on the smaller side. Obviously, we can conclude that the number of passengers, dead passenger was more than the number of passengers who survived the accident. Now, if you want to execute this particular part of the program, I will do it, and maybe that I will stop because I have to keep on shifting from one program to another, and that makes it difficult for me. Okay, so I am trying to execute this on the program editor. Just hold on. I think I'm having a lag. Okay. So I'm going back to my program, and now I'm writing the code for displaying the graphics. Okay, so I have the code on the editor. Okay, I will be generating the graphs for survived, and then survived with sex, survived with class of travel, age of the passengers, and the fare. Okay, I'm executing this program now. I hope you can see this on the screen.
Yes, sir.
Okay, so the program was executed, and you get this kind of graphics. So this is the graph for survived, and survived on the basis of the class of travel. Okay, like this, you will find graphics are being generated for about 4 to 5 variables. I'm going back to my slide so that it becomes easier for me to talk. Okay. Okay, so this is the graph for survived. Then this was the graph for survived and sex. So you will find that the blue color bars are representing males, and the orange color bar represent the females. There were more deaths among male compared to the females. Okay, and if you try to recollect the story of Titanic, you should recollect that the females and the children were allowed to leave the ship first and go far away from that accident place. That was then followed by the first class passengers, followed by the elderly people, And if you try to match this particular analysis with the storyboard, it will it matches very much. Then we have the graphics for the class of travel. So you will find that there were more deaths in the third class passenger. The green color bar represents the third class, okay, and lesser deaths were in the first class, okay, survival more in the first class. So like this, you can just connect to the story of Titanic, the movie, and here it tells, you know, how the story writers have made use of this analysis. So this was all about the graphs and the descriptive part. Now, if you look into the output of this particular data set, you will find this is the output, wherein in case of age, the number of observation is quite less. In case of cabin, it is still less. Okay, so age, you have 714 observations, and in case of cabin, you have 204 observations. If you have this kind of missing data, then it becomes problematic for us, you know, to generate, to analyze such data. So what we can do is, if wherever possible, you can go for something called as data imputation. So what is data imputation? There are about 5 to 6 methods of data imputation. The most easiest method is finding out the mean of this 714 data points and imputing the mean value in place of the missing values. Okay, or you can also calculate the median of this 714 data points and impute this median value in place of the missing values. Okay, and in case of cabin, you know, it is going beyond our expectation, because if you have missing values more than 5% of the total data points in your data set, then you have problem in hand. Okay, you will have to either treat those missing values with data imputation methods, or you will have to drop the variable. So in this case, it would be feasible for us to, you know, impute the missing values in case of age, and it would be feasible for us to drop the information, the variable called cabin. Reason, the information in cabin may not be that useful for developing my logistic regression model. We'll come to this later on. Now, if I generate the histogram of the age of people or the passengers on the ship, you will find that most of the passengers were in the age group of 20 and 40. Okay, most of the passengers were in the age group of 20 and 40. As far as the ticket fares are concerned, you will find that obviously the first class ticket fare was at the high. Now, I will try to find out, apart from the variables like age or cabin, whether any other variable are having missing values. Okay. Now, this is a very small data set, you know, for us to use a machine learning algorithm. Okay, because, you know, the data sets having sizes of more than million records, maybe 1 million, 2 million. Okay, there you make use of the machine learning algorithm. So here it was quite easy for me, you know, to find out whether the other variables have or do carry the missing values. For instance, you know, we worked on a data set for a multinational organization where we were having, you know, data rows more than 10,000, and the number of variables was 36. So in that case, I have to make use of the Python program to find out whether any variables are carrying missing values. Okay, so under the circumstance, I have made use of the Python program statements and have generated this result. Now, where you will have Boolean output. Okay, so you have the names of the variables at the top, and then you have the Boolean values like false and true. So wherever you find false value, meaning that the data point is not empty, and wherever you find true, you should know that the data point there is having a missing value. Okay, so you can make use of something called as Titanic.data is null. So is null is a function of Python by which we can find out what all variables are having the missing values. Now, apart from this particular concept of finding out the missing values, you can make use of something called as a heat map. Okay, so in case of heat map, you get a very clear clarity about the missing values. So this is the heat map generated for the 10 variables in our data set. So in this case, you will find that the background of the heat map is totally black, and then you have some white color segments in the variable of age and in cabin. Now these white bands represents the missing values in the data set. So this heat map again is yet another tool by which you can find how many of these variables are having the missing values. So for passenger ID, survived or dead, P class, you don't have any missing values. These are the only two variables having the missing values. Now, I was talking about data imputation. So wherever you have that those missing values, you will have to impute that data with the mean calculated. For example, you have about 790 values, 714 values in the variable of age. I calculate the mean of these 714 values and I impute this mean value in place of the missing values. Okay. Now here the question is whether the age of the passengers are evenly distributed over the passengers travel class. Okay, so can we find equal distribution in 3 travel class of the ship? And in order to find whether there is an equal age distribution in the 3 travel class, you can generate a graphic of this type. Okay, now here we have generated a graph called as a box plot. At the x-axis you can see the 3 classes displayed: first class, second class, and the third class. And on the y-axis you have the age distribution. Okay, for first class, the mean age. So if you look at the black color lines somewhere between the box, that represents the median of the age. So if you look at the 3 classes, you will find the medians are all different. Okay, now here you can also locate the mean in the box plot. Okay, so I can conclude that the mean age of the passengers traveling in first class was higher compared to the second class and the third class. So what is the way of data imputation for me over here? Mind well, no books will tell you all these facts. Here, these facts will come to you only through your experience. Now, in case of data imputation, I am going to impute the means separately for first class, second class, and third class. Okay, any questions on data imputation? Okay, fine. Okay, so I try to do data imputation by developing a function in Python. So what I have done is I have calculated the mean of age of the passengers of first class, the mean of age of passengers of the second class, and also that of the third class. Okay, so all the missing values of age in the first class will be imputed by the mean of first class. Similarly will be for second class and third class. Now this will give me a proper picture of data imputation. In fact, if I I try to impute the data by taking the means of all 714 passengers age, it won't be wrong as such. But if at all you want to head for more accuracy, then this is the best way of doing the data imputation. Okay, the box plot shows you that the means of the ages are different for different travel class. For example, the age of passengers in first class is higher compared to the second class and the third class. So the best way, I repeat, the best way of data imputation will be, using the age of the first class passengers, calculating the mean and imputing the missing values by that calculated mean. You repeat this procedure for both the remaining both second class as well as the third class. Okay. Now, so this is how we do the data imputation. Okay, so for each class we have done it separately. Now I'm going back to my heat map to find out whether all the missing values are being replaced by the arithmetic means of the three classes. So here is the heat map. Okay, now we have not touched the cabin wala variable, and we have done imputation only for the age variable. So in case of age, you will find that there is not a single white band present. The only variable where you find a white band is cabin, because we have not touched this variable of cabin. Okay, the number of missing values in case of cabin is too large, and therefore it would be feasible for us to drop this variable at a later stage of the program execution. Okay, so this is how we are going to drop this variable called cabin, and we make use of a function in Python called as drop now. Okay, now some of the variables, for some of the variables we are going to convert them into something called as a dummy variables. So wherever you find the categorical data is present, okay, you can convert that those categorical data into dummy data. So here we are creating dummy variables for sex and embarked. Okay, because in case of the gender you have males and females, and in case of embarked variable you have the three levels of classification. That is, I think C, Southampton, S, and there is one more. So you have three variables, variable levels under the embarked column. Okay. Now, if I try to make use of the text that is present in the Excel sheet, okay, for example, if the passenger is a male, so we write male under the column of sex, and for embarked, we use the first letter, the abbreviation of the boarding code. Okay. So now this kind of data is rather difficult for us to analyze on the Python platform. So we have to convert those things into numericals, and the best way out is converting these categorical variables into dummy variables. So this is how the program looks like. Now if I execute this program, I should get the output of this kind. So you have the first row of the data, and in the first row you have the information of a male passenger. So that dummy variable, the categorical variable of sex will now carry two dummy variables, male and female. So if the first passenger is a male, you will get a 1 under male and a 0 under female. Okay. Now in case of the second passenger, okay, whose identity number is 1, the passenger is a female, and you get a 0 under the male. So in this is the way you try to create dummy variables for categorical variables. Any doubts till this point of time? Maybe that it would be a little bit difficult for you all to understand, because we are not trying to go through the entire exercise on the Python platform. I've already mentioned that downloading Python, downloading the libraries will take at least 45 minutes, okay, of the installation. So I thought it is better that I just keep on demonstrating these two case studies. Any doubts till this point of time? Okay. Now, the data set which we have of Titanic will now be divided into two parts. One is called as the training data set and the other one is called as a test data set. So can anybody tell me why we need to have a training set and a test set? Anybody? I think you have gone through a number of sessions till this point of time, and you should be in a position to tell the difference between the two, or rather why we need these two types of data set in our analysis.
Training set is to learn the machine, to make the machine learn, and testing is whatever it has learned, whether it is correct or not. That is
absolutely, yes, absolutely correct, Dr. Seema. The training data set is used for constructing our predictive model. So the regression model will be constructed, logistic regression model will be constructed on the training data set. Now, how would you know that the model constructed will give you a high level of accuracy? So you need to test that model, and in order to test that model, you have to make use of the test data set. Okay, so what we are doing now is converting the Titanic data set into two parts. The first part will be known as the training data set, and the second part is known as the test data set. Now, the percentage of observation, certain percentage of observation will go in training, and the remaining percentage will be in the test data set. It is at the discretion of the researcher, like what percentage should go in training and what to go in the test data set. In this case, I have made use of 70%, 30%. So 70% of the observations will be in training data set and 30% will be in test data set. Some people make use of 80%, 20% ratio as well. So it is totally at the discretion of the researcher how to divide the data set into training and test. So this is the algorithm, part of the algorithm which converts the Titanic data set into two parts. Okay, now I told you that if at all you want to make use of some machine learning algorithms, the scikit-learn library is the most ideal one, and here you will see from the part of the program that the scikit-learn library is being used, and from that I'm importing the function of logistic regression. So this is the part of the program which will help me to develop the regression model. Okay. Okay. So in this case, what are we trying to do is we not only fit the model to the training data set, but then we also try to test that model on the test data set. And in order to test the model, we have to create something called as a confusion matrix. Okay. Now, let me display that. Now, this confusion matrix will give me information on the accuracy, precision, recall, and something called as a F1 score. Okay. Now, let us try to understand these in short. I know that talking on the confusion matrix for 2 or 3 minutes will not suffice, but that is the only possible way for me to describe whatever is possible through this lecture. Now, this is known as the confusion matrix. Now, suppose you have the actual observations, and then based upon the actual observation, you are trying to make some predictions. Okay. So you have a binary classifier of some disease. I'm a little bit diverting away from the Titanic data set just to make you understand the concept of this accuracy, precision, recall, and F1 score. Okay. So we have some data set of 165 patients, okay, and they are being tested for a particular disease. So actual is no disease, and actual yes means they carry the disease, okay, and then you have the predicted columns. Now in this case, out of the 165 observation, 50 observations were predicted correctly with no disease. 100 observations, made the correct predictions. Okay, because actual is 100 and predicted is 100, so you have 100 observations, the predictions made correctly. Then these values of 150, this is called as a true positive value, and this 50 is known as a true negative value. So true positive is something wherein you have the actual observed values 100 and the predicted values 100, and in case of true negative, actual observed values 50 and predicted no also 50. So these two are called as true negative and true positive values. Now you have some false predictions made by your algorithm. So these false predictions are called as false positives and false negatives. So in this case, let us try to look into false positive. Okay, the actual, these people were actually observed with no disease, but the predictions is with disease. So these are false predictive, false positive values. And in this second row, you will find that the observed patients did carry the disease, but the predictions were no. So these are called as false negative. Now, based upon this information extracted, you can define those four terms over here. Okay, accuracy, precision, recall, and F1 score. Now here, there is something called as accuracy, which is calculated by the formula true positive plus true negative divided by the total number of observations. So from that table, you will find that there were 100 true positive, 50 true negative values, and the accuracy level came to 0.91. So in this case, the prediction is 91% accurate, you can say. Then you have the misclassification rate. So even though you can calculate the misclassification rate, misclassification ka matlab hai, you have false positive and false negative values. Okay, so obviously you don't require this calculation. You can subtract 0.91 from 1 and you get 0.09. But still, if at all someone is interested in the formula, it is a false positive plus false negative divided by the total number of observations, and that comes to 0.09. Then you have true positive rate. So true positive rate will be the value of TP 100 divided by 105. Okay, so why 100 out of 105? Can anybody tell me? True positive. Can anybody tell me why it is 100 divided by 105?
Predicted yes, that is 100 divided by actual yes, total of actual yes, that is 105.
Yes. So that accuracy level comes to, that accuracy level comes to 0.95. And similarly, you can calculate the false positive rate. Now, here, through these four concepts, you can just determine the accuracy level of your model. So I think I have the accuracy level over here. So here, you have in the first column zeros and 1. So the people who did not survive the accident, and 1 people who survived the accident. So look at the precision rate. You have 0.77, 0.76, recall, and then you have the F1 score and you have the support. Okay, now all these concepts tells you that the accuracy of the model is quite acceptable. Now, even if you look at the matrix at the bottom, you will find that 126 and 79 were accurate predictions, and 25 and 37, okay, were inaccurate predictions. Now, this is on the test data, and therefore, this test data was 30% of the total observations. So this amount totals to about 267 observations. So this performance matrix is based upon the test data, and then you can have the final value of the accuracy. It is almost 77%. So by this time, we understand that the model is giving us 77% accuracy. the classification rate is good enough to be accepted as a good model. Okay, so that was all about the logistic regression. Now I have one more data set to talk on, and that is something called as a California housing project, and this is in fact an end-to-end machine learning project. Now let us straight away go to the problem we are trying to solve for the people of California, and that is housing has been a topic of concern for all Californians due to the rising prices. It leads to the question, why are homes in California so expensive? Okay, now in all we have about 10 variables and 20,640 observations. Okay, now each observation represents a single block of houses within California. And then, we have a variable called as ocean proximity. Now this ocean proximity has got 1, 2, 3, 4, 5 levels. One is, the first level is 1 hour drive from the ocean inland, and then you have near bay and near ocean. Sorry, 4 it is. Okay, so we have 4 levels of classification under the variable ocean proximity. Okay, and then we have information on a variable like what is the median age of the houses in California, what is the median income levels of the people in California, what are the house values prevailing in the state, and then we also have to understand through the data set that incomes or the median ages are rounded off. Okay, they are rounded off, plus the housing prices estimated are for each block. So I would like to now present the data set on the screen. Okay, so this is the data set, and if you scroll down, you will find there are about 20,641 observations. Okay. Now, if I run this program on the Python platform, I get the first information I get is this. So the first column represents the variables in the data set. So there are about 10 variables and they are given the index number starting from 0 to 9. So we have 10 variables. Okay, we have the latitudes and the longitude information of the housing blocks in California. So mind well here, total number of bedrooms variable is having less observations. Okay, so all the other variables are having complete data. Only total bedrooms we are having some missing values. Okay, so in all 207 districts in this variable of total bedrooms are missing. Information from 207 districts is missing. So what next now? We try to find out something more about that ocean proximity wala variable, and I've already mentioned that it is having more categories under it. So 1H is the housing blocks are 1 away at a 1 hour drive away from the ocean. We have something called as inland housing blocks. We have housing blocks near the ocean. We have housing blocks near the bay, and we have housing blocks on the islands near California. Okay, so here we have tried to understand, something more about this ocean proximity variable. Now, the very basic thing we do, at the start is generating a descriptive statistics report. So in this descriptive statistics report, you will find that the minimum values are calculated, the first quartile, the median, the mean, the third quartile, the maximum values are calculated. And this process is repeated for all the 10 variables in the data set. In fact, the information on latitude and longitude, will be of no use as far as the descriptive statistics is concerned. But definitely, the descriptive statistic report will carry some meaning for the remaining 8 variables. Now, what next? So here, we'll try to understand, the descriptive statistics by taking 1 or 2 variables here. Okay, so if you consider median house value, okay, the minimum value of a house in California is $14,999. The first quartile stands at $11,960. The median stands at $17,900. Mean is $20,6856. Likewise, you have the third quartile and the maximum value of the house. Okay, so like this, you can dissect each and every variable in the data set. Okay, ocean proximity we have already done. Now, why I have taken ocean proximity? Because this particular variable is a categorical variable. Okay, so in this case, you can just have the readings of the observation under each category. Now, the second thing which we do in descriptive statistics is try and generate, the histograms for each of the variables. Okay, so here you will find that majority of the histograms, for example, you consider total rooms from total rooms, okay, 2 median house values, you will find that the right tails are quite extended. I hope people know something about the normal distribution. Are you aware of normal distribution?
Yes.
Okay. So, what observation can you make on the histogram starting at okay, you can say median age to median house values. So if you have some knowledge of normal distribution, so what comment can you make on these histograms starting from housing median age to median house values?
Sir, the screen is not visible.
Is it? Okay, I'm sorry for that. Okay, so my question was, if you know something about normal distribution, then can anybody comment on the histogram starting from this point, median age to median house values? No idea? I think somebody said that the lady is having some information on normal distribution. Okay, so if a variable is following normal distribution, what comment can you make on that variable? Why are we using normal distribution? For what purpose? I hope those who have done their PhD, they should be in a position to answer this. So the answer is, if I know that a variable is following a normal distribution, giving me a bell-shaped curve, I should be the happiest researcher, because then I can make a choice of my statistical test. Okay, you can, if a variable is giving you a normal distribution curve, then you should know that parametric test should be the obvious choice, and applying parametric test will be quite easy than using applying the non-parametric test. So normal distribution will speak about what test we can apply in statistics Normal distribution will also speak about the outliers that may be present in the data set, so on and so forth. Apart from that, the shape of the curve will tell you whether the data are skewed or not. The shape of the curve will describe about the peakness of the normal curve. So if you will find that the data is not giving you a normal bell-shaped curve. Now, in case of say total rooms, you will find that the normal bell-shaped curve is not to the perfection, and the tail of the bell-shaped curve on the right-hand side is getting extended. So if you try to have a look into all these histograms up to median house values, you will find that the right tail are elongated. Under the circumstance, I understand that the data under these variables are skewed data. Is it okay? Or I am going to technical?
Yes, sir. Positively skewed, sir.
Yes, positively skewed. Okay. So like this, I keep on tracking information about all the variables so that I can treat these variables properly at a later stage, because I expect the variables to give me more or less the bell-shaped curve. It should be near to the symmetrical curve. But in reality, it is not possible for us to obtain such perfect bell-shaped symmetrical curves. Okay. So if the skewness of the variable lies somewhere between plus or minus 0.5, I am going to accept that variable as following the normal distribution. The moment the skewness value goes beyond this range of plus or minus 0.5, then I should understand that I should give some statistical treatment to the variable and go for a process called as transformation, variable transformation. Now again, this is something a different topic. Now today what I'm trying to convey is the power of the regression models and the machine learning algorithms. Okay, so till this point of time we have understood that apart from longitude, latitude and the ocean proximity carries no meaning because it is a categorical variable. Uska histogram banega nahi. Okay, but rest all the variables are skewed. Okay, so this information we have obtained about the variables in the data set. Okay. Now, let us try to understand more about the patterns through these histograms. So the summary of more insights is given on this particular slide. Now the first observation of mine is that the median age shows mostly randomness because there is a peak at the end, and that provides a confirmation that there is a cap on the maximum value. So if I go back to the slide, you will find that there is one bar at the end of the histogram which tells me that the people who have generated the data set, they have rounded off the values to a particular value. Uske baad ke values unhone liye nahi, unhone round off kiya hai. And that is why you find that the bar on the extreme right hand side. Okay, then you have as we have already mentioned that the other histograms are showing the features of skewness to the right. Okay, and then here even the median house value showed expected peak on the far right. So if you have the expected peak on the far right, median house value. Okay, here also in median house value, the one histogram at the bottom shows you the a bar with a good height at the end. Now this speaks that people have rounded off the median house value to $500,000. Uske baad ke value sab idhar sama gaye hai. Now if this is the case, then you may not have accuracy in your analysis. Okay, you will have to talk to those people who have created the data set and get this problem rectified if at all they are interested in the accuracy of the analysis. Okay, then if you look at the graph, I told you that इसका latitude और longitude का कोई ज़्यादा मायने नहीं रखता है from the statistical point of view. But here and in these two histograms, you will find that there are two peaks. Okay, so in longitude you have a peak over here, and here the second peak is on the right hand side. Similarly, you will find the first peak on the left and one small peak on the right hand side. Now, what does this indicate? So if you try to read the latitudes and the longitude on the graph of California state, you will find that there are more people residing in Los Angeles and San Francisco. So if you try to get into the graph of California, you can read this from the latitude and the longitudes, and then you can come to a conclusion that there are more, the density of population is more in Los Angeles and in San Francisco. So this is how you try to get into the patterns of different variables in the data set. Now, again, like we did convert the main Titanic data set into a test data set and into a trained data set. Likewise, we are doing the same thing over here. Okay, I am making use of the algorithm, trying to divide the main data set into two parts, the trained data set and the test data set. So here, I am making use of the 80-20 ratio. 80% will go in the trained data set and 20% of the observation will go in the test data set. Okay, so the total number of observation in train is 16,512 and in test it is 4,128. Right, now if you look at the histogram of income किधर गया, median income. If you get into the histogram of income, again you will find that the income histogram is having skewed data. You have an extended tail to the right. So under the circumstance, if at all I want to analyze this data set, then first thing is try and find out how this income is distributed. So what I will do is, income is something which is a continuous variable. Okay, and looking at the numbers, 20,641 numbers, it is difficult for me to understand the distribution of the variable. What I will do is, I will try to convert this continuous variable into a categorical variable, and for that I would be creating bins. So income between 0 and 1.5, 1.5 to 3, 3.5 to 3 to 3, 4.5, so on and so forth. So I'm going to convert income into bins, 0 to 15,000, 15,000 to 30,000, so on and so forth. Okay, and I'm going to label them as 1 to 5. So if I execute this program, okay, I'm unable to show this because I have to keep on shifting from one program to another. But still, if you're interested, I will show you how long the program is. Okay, you can just see how long the program is. Okay, and that is the reason why I'm not typing the program and getting that executed. Anyways, let us go step by step then. Okay, so I convert this income variable into a categorical variable. Previously it was a continuous variable. Now we are converting it into a categorical variable. So having converted that into a categorical variable, you get the distribution of this kind, and you will find that the median income of the people residing in the state of California, okay, wherein you will find there is a lot of diversity in the income distribution. Okay, so you will find two large bars at the center at 2 and between 3 and 3.5. Okay, so you will find that the distribution of income of the people staying in the Californian state is uneven. Okay, now if at all I want to create a test data set, so here we have taken 20% of the total observation as the test data set and 80% as the trained data set. 80% of the observation going into the trained data set. Okay. So what I will do is I will try to ensure that if at all I want to create the two data set, trained and the test data set, then I should take this income variable, median income variable, because that is the main variable, you know, that will play an important role in deciding the purchase of a house in California. In fact, it is everywhere. जैसा income है वैसा घर खरीदे जाएगा. So under the circumstance, I want to now ensure that, you know, all these income levels, 5 levels are present in my two data set, the trained data set as well as the test data set. So if I'm picking up, you know, equal distribution in both the data set, perhaps I can expect a high level of accuracy in my analysis. Am I clear? The thing is that for the last about 1 hour 45 minutes I am speaking and you people are listening. I'm unable to understand to what extent you are able to grasp this. So we are trying to understand the distribution of income, median income of the people in the state of California. So what is the conclusion we have drawn? Anybody, please? I'm asking you questions just to find out whether you have understood, and if not, then I can, you know, explain it once again. So why are we trying to understand the distribution of income, median income of the people of California? I think I have already explained this. I think half the people have just kept their comms open and are, you know, shifted elsewhere. Any answer, please? Okay, anybody wants me to explain it again?
Yes, sir.
Yes, Vijay Kumar, what do you want me to do? Have you understood why we are trying to understand the distribution of income? The reason is that income is going to play a major role in the purchase decision of a citizen in California. In fact, it is true everywhere. Okay. Now, if at all I want to divide this data set into two parts, the trained data set and the test data set, I have to ensure that both the data sets are the true representative of the population set. So if you know something about sampling, then you draw a sample in such a way that it becomes a true representative of the population set. Putting in other words, all the characteristics of the population set must be there in your sample set. Then only you ensure that the sample set is a good representative, and the analysis which you draw from the sample data, you know, we can accept that analysis through statistical test to be the parameters of the population set. And that is the reason we are trying to, you know, divide the full data set into two parts, train and test, to ensure that the income is properly distributed in both the data set. So through this particular program, we have seen that various bars are displayed, and these bars indicate that the income distribution is highly uneven. Okay, I want to ensure that both the test and the trained data set will carry, you know, the data points from this variable which are evenly distributed. Evenly distributed का मतलब क्या है? I will pick up a proportion from the first level, okay, a proportion of the second level, a proportion from the third category or the third level of the median income, and ensure that this proportion is present in both the trained and the test data set. And this is what we achieve on the next slide. So I will be using something called as a stratified sampling. Okay, and I have a ready-made function called stratified shuffle split in scikit-learn library. Okay, I don't have to write program statements to do all these things. I just borrow these functions from the libraries and I get them executed. It is that easy. Now you will find that we have 5 strata, and with this program we have divided the data set into test and train, and we have made use of the stratified sampling. So this table on the right hand side indicates that it is 4% of the data points coming from category 1 of the median income variable, 32% comes from level 2. So here you will find that the first bar is a very small bar indicating less number of people in this category. Then the second bar is having a substantial height, and that is the reason the program has picked up 32% of the data from the second category of median income, 35% because the third bar is still bigger. Okay, so 35% of the data points are picked up from the third category of the median income. Likewise, 18% from 4 and 11% from category number 5. So what we have done here is we have ensured that both the test and the trained data set carries equal proportion of observations of the median income variable. I hope you are able to get this. Okay. Now, I try to plot this data and I will get this kind of a graph as the output. So on the x-axis, you are plotting the longitude, and y-axis, you are plotting the latitude. Okay. Now this graph, the data points are nothing but the points coming from your data set. Okay. Now, how would I know that these latitudes and longitudes are representing the map of California? So for this, I've picked up a map of California, and you will find that the shape of this map and the previous map is just the same. So the blue color dots in this particular map indicates the housing blocks in the state of California. Now again, this is not giving me much of the information. Okay, under the circumstance, I will improvise my code, and then I will try to convert those points into dark points and maybe some faint colored points. Okay, light colored points. Now the dark points on the graph indicates that these are the areas in the state of California which carries high density population, and the light color shade indicates the lesser density population places or the blocks. Are we clear? So from one analysis or one Python program, you can extract as much as information as possible right from the descriptive statistics. You can visualize the data, and you can also fit appropriate predictive models. You can develop predictive models. Okay, so that is the beauty of analytics. Now here we are trying to answer to the question like why housing is so costly in the state of California. Of course, today we will not be able to complete this analysis because it is a very long process. So jitna hota hai utna main kar dunga. Now, if I want to still further dent into the patterns of housing, then what I will do is I will try to add one more variable to my analysis, and that is median income house values. So on the right hand side, you will find that a bar is shown with different colors, and the colors indicate the values of houses in the state of California. So for example, if you have a blue color dots on the graph, you can understand that the approximate values of houses in this blue color dots or the blocks is near $100,000. So as you move from the bottom of the scale to the top, that is $500,000, you can easily locate, find the locations where the housing is pretty costly. Are we clear?
Sir, I have one doubt. Can I ask you a question?
Yeah, go ahead, please. Go ahead.
So instead of can you please go back to the 2 slides previous? I mean, on
Which
that sampling.
On the
on that sampling, stratified sampling.
Yeah.
So instead of this stratified portion, my question is: can we do oversampling of the rare events? I mean, instead of giving higher weightage to the events which are higher in number, because most of them having a high income groups.
No, I didn't get your point. Please come again.
So income, I mean, you are gonna take the sample. 35% of the samples are gonna come from the people who are having a higher income, right?
Yeah.
And only 3% of the people who are gonna come from the, I mean, the samples that are gonna come
lower income, right?
So
Yes.
So instead of it, can we, I mean, increase the representation of lower income group into these data sets? So increasing the rare events, I mean.
You can do that if at all you want to address to that problem or to a problem connected to your statement. Okay. But now, since I'm, trying to develop a sample which is a representative of the population set, then I have to bank upon these proportions. Otherwise, you won't call that as a true the sample representing the population in a true sense. Okay, as far as your statement is concerned, you can always go for a adjustment in the sampling. If at all you want to, increase the presentation of the lower income group, you can very well do that, provided you have a problem to solve. You can always do that.
Yeah. So as of now, by just adding 3% of the samples of lower income in my population, I mean, we are reducing the representation of lower income group into this analysis.
No. In fact, you have only, the 3% of the population in the California state, whose income is on the lower side. Okay. So you have to pick up, appropriate proportion from each category of median income. Then only you can claim that your sample is a true representative. So if you try to increase the number of people from the lower income category, you increase the number, then it is not going to suffice our cause. Okay. So if at all you want to express your sample as a true representative of the population set, you must have these proportions calculated. And you don't have to do it, in fact, that function of scikit-learn will do it for you. You can always increase the proportion of lower income group, provided you are addressing some problem related to lower income group. You can do that.
Okay, so thank you.
Okay, so here, you just add one more variable to your program to find out how are the prices of the houses in the state of California. Okay. Now, I think, even if you get some gist of how powerful, data analytics can be, I think I have made my day. Maybe, you people may not understand, the technical part of all this, but I hope if you are able to understand how powerful data analytics can be in developing strategies, I think, I have made my day. Anyways, in 1 or 2 slides, I will try to complete my presentation. So here, okay, my dependent variable is median house value, and the remaining variables are the independent variables. Now I'm trying to develop a correlation matrix to find out to what extent the independent variables are related to the dependent variables. Mind well, in regression analysis, there must be an appropriate relationship between the independent variables and the dependent variable. If that relationship is absent, there is no point in having such regression model. Okay, so this is the correlation matrix, which tells me about the relationship of all these independent variables with the dependent variable. Now, how can I improve the situation of the correlation matrix? I can very well do that. Now, why there is a need for me to improve the correlation between the dependent and the independent variable? Now, the next graph will tell us that why there is a need to improve upon the correlation between the dependent and the independent variables. Now, you will find that on this particular graph, there are some horizontal lines appearing. So, at the value of 500,000, you have a horizontal line. Somewhere at 48,000, you have a faint horizontal line. At about $35,000, you have a horizontal line. Now, all these lines indicate that the values are rounded off. Okay. Now, these rounded off values, previously also I told you that these rounded off values can create problem in your analysis, and you have to get them resolved by the people who have created the data set. Okay, so this correlation matrix speaks about a problem on hand, and that is the reason why I will have to improvise upon my correlation. Okay, so the output of this graph is the correlation sounds to be very strong, because you will find that all these 20,000 odd points are very near to each other and they are showing a positive correlation. Because if I try to plot a line passing through these points, then it will be a line starting from the lower left corner and approaching the upper right corner. So there is a positive correlation between the median income and the median house values. Okay, then you will find that there is a price cap which is visible by a horizontal line at $50,000, 500,000. You have a horizontal line at 450, 3,500,000. Okay, so likewise, these lines are indicating some problem, because there are data points which are quite repeated a number of times. For 500,000, for observation of $450,000, so on and so forth. And these repeated values in the data set can create some nuisance in our analysis. So what can we do? We can then improvise the values under 3 variables, that is rooms per household, bedrooms per room, population per household. Okay, I'm trying to use some mathematical formulas to improve upon the values under these 3 variables, because the number of rooms per household, okay, the number of rooms mentioned are in one particular block, okay, in one particular district, and I'm not interested in number of rooms in one particular district. I'm interested in number of rooms per household, the average number of rooms per household. So if I try to change this scenario in these 3 variables, can I get a better correlation? So if I write this code, okay, use these formulas and try to convert the values under these 3 variables on the left hand side into new variables, then I get a correlation of this type. Okay, and these correlations are better off compared to the previous correlation. Then I will try to make use of these 3 new variables. Okay, and then I will have to do something like data cleaning, where I try to find out the number of missing variables under each variable. If possible, if required, I have to do the data imputation. Okay, and then make the data set fit for the application of machine learning algorithm. Okay, now again, the categorical data in the ocean proximity variable will be a problem for us. So we try to convert this into the dummy variables. Okay, so I think I'm exceeding my time. So let us try to find out finally what I have done. So finally, we have created a few models which speaks about the accuracy. For example, we have created something called as a regression model. Now this regression model is giving me trouble because root mean square error is too high for the regression model. So I may not accept the regression model. In this particular exercise, we have created a number of models. For example, we have created a regression model. We have created a decision tree model. Okay, and then we try to compare which model is the best one, so that we can make use of that model for final prediction. So here we have created a model called as a regression model, wherein my root mean square error is very much on the higher side. Okay, so here the mean of this variable, dependent variable, comes out to 68,628, wherein the majority of the values lie between $120,000 and $265,000, which means that this value is not a good representative of the data. So here, this is an example of underfitting of a model. Okay. Likewise, we have calculated a decision tree model, and the decision tree model, again you will find that the error term here comes to 0. Okay, and the standard deviation is very high, and therefore I cannot accept the decision tree regressor. Okay, likewise, I have created a random forest model, and in random forest also you will find that the value of the error term of that model is on the lower side, and therefore I can make use of the random forest model for my predictions. Now this is all I can accommodate. I don't know to what extent this was helpful to you, because I think it was a little bit technical. Thank you very much.
Thank you, sir, for your insightful elaboration on this case study. And with this, we will end our pre-lunch session. And at 2:30, we are again gathering back for the next session. So have a nice lunch, and thank you very much, Sachin, sir.
Thank you. Hope
Thank you, sir.
Yeah. So if you have any questions, you can put me the questions. Pranjal sir will convey the questions to me. Okay.
Yes, sir. Yes. So participants, if you have any questions, you just write me those questions either on WhatsApp group or in chat. Chat is on. So I will convey these questions to our director, and he will answer you.
So, Pranjal sir, there is one thing we should convey to our participant, that tomorrow they'll be having a assessment, and that assessment will be from 5 to 6. So accordingly, they have to plan from today itself that they make themselves available from 5 to 6, because this timing is sacrosanct. I mean, there won't be any leeway for us as a coordinator of the program to allow you more time. So kindly, I mean, we'll share the link 5 minutes before, and we'll close the link at 6 o'clock. So, I mean, with a humble request to all our faculty colleagues that please take out your time, arrange your bandwidth, be available so that you can give your examination, and then it will not be a big problem for us, because we would not be in a position to accommodate any request to extend the time.
Correct, sir. So it's humble request to everyone, and by end of the day today, we are going to send you all our video records and the other material as a common folder link share, because many of you have requested because you need to study. So we'll definitely provide you by the day. Fine. Thank you very much. Thanks. Good afternoon, Professor Archana.
Very good afternoon to you, sir, and very good afternoon to all the participants.
So we still have 3 minutes, ma'am. After 3 minutes, we'll start.
Sure. I'll try and present my screen till that time.
Yes. Madam, I was just wondering if you can share this reading material or anything else with the students, because tomorrow they have assessment, no? So your PPTs or any other reading material which you want them to read to go, to attempt that exam. If you can share, so we'll put it in the common drive and share with them.
Sure. I've already shared some of the things with you all, like the case study is there.
Yes.
Some MCQs, etc. are there. And
MCQs for the assessment, but any other supporting reading material if
sure.
you want.
Yeah.
So good afternoon, participants. This is a post-lunch session. I know this is going to be a little heavy session for every one of us. So we have Dr. Archana Srivastava with us today, and she will just continue her last session, data-driven HR domain. So she will continue with that theme for this session as well. Over to you, ma'am.
Thanks, Pranjal sir. Rightly said, difficult time soon after lunch. But anyways, I'll still try my best to keep you alive and to keep you engaged with the topic here. So this, of course, is the second session as far as, just give me a minute. Yeah, sorry. So we'll continue with this second session. I think the first session that we had done, we had tried to build the context why HR analytics is important. We discussed about the LAMP model. And we also took up an example through which we tried to learn as to how we can take managerial decisions which are based on the data analytics. So that was there in the first session. Today I'll take it forward, and I will just share my screen. So I would want somebody to confirm to me that can you see my slide?
Yes, ma'am. They are visible, but they are not in presentation mode.
Right. So now it's in the presentation mode. Right. All right. So today I intend to cover and speak a little bit about these topics. So today we'll be learning how do we move, how do we undertake that journey from moving from metrics to HR analytics. So that's how we will be building the session today. I'll be talking at length about what are lagging indicators and what are leading indicators, because these are very, very important when we are trying to do analytics. And the goal of HR analytics always is to improve organizational outcomes. And it is in this context that lagging and leading indicators become very, very important. Which to choose, which not to choose, which is a lagging indicator, which is a leading indicator, can they be the same? So this is what we're going to discuss after this. After this, I'll take up a case scenario where we will try and develop a predictive model in the context of employee resignation. So we will try and predict, who are those employees who have an intent to resign. So that would be the case scenario 1. After having covered, these quantitative aspects of HR analytics, I would also want to talk about qualitative analytics in HR. In this context, I would be taking up 2 cases here. So the first case that I want to talk about is the truth and exit interviews. And the other case that I would be talking about, how we can use social media analytics to understand behavior, to understand sentiments of people, and then can we design a strategy in response to that. So that would be the case number 3. Briefly, I'll be talking about the dashboards in HR. Finally, the benefits and challenges of HR analytics. So roughly, this is the roadmap that I have for today's session. In the next 2 hours, I'll try to deliver this. So from opinions to insights. So first of all, you may have an opinion about something. but it may just be an opinion. Remember, your perception about something, about somebody may or may not be the reality. So we need to further collect data based on this. And when we collect data, we will be subjecting it to analytics. But before we subject it to analytics, we need to have some measurement scheme. How are we going to measure a certain construct or a certain variable? So for example, employee engagement. So it's a complex construct. So how are we going to measure employee engagement? How are we going to measure the intent to resign? How are we going to measure employee commitment? How are we going to measure perceived organizational support? So we need to design some sort of a measurement scheme or some sort of a measurement tool. So this is where your metrics comes into the picture. So data, right? Then how are we going to use that data? What will be that scheme? That is metrics. This metrics then becomes the input for analytics. So in HR, when we are collecting data with the intent of analyzing it, we should ensure that we have analytics ready metrics. That means metrics which will readily lend itself for further statistical analysis, right? The output of analytics is where we will be able to draw insights. This is where we try and interpret what the data is saying. And these insights should be actionable insights. When the insights are actionable insights, then we are able to, do evidence-based management. So that is the journey from opinion to insights. Opinion, you may start with an opinion, collect the relevant data, have metrics which are analytics ready metrics, analyze the data using a suitable tool, a suitable technology, and from therein you're going to derive the insights. A little bit more in detail about metrics. So what are metrics? Basically, metrics deal with operational data. So data that you're going to collect from the real world. So that metrics is going to deal with data. And why do we have these metrics? Metrics will help you determine two things: the efficiency and effectiveness of HR processes and outcomes. Right? We all understand the difference between efficiency and effectiveness. Efficiency is doing something right, whereas effectiveness is doing the right things. So when you have these metrics, then they will help you determine whether your HR process, your HR outcome is efficient and effective, both. If we talk in statistical terms, metrics are the relation between the data points. So let us say employee engagement. You've got 100 employees. You're going to calculate, you want to calculate their employee engagement levels. So you're going to collect data. You're going to circulate maybe a survey to them. You're going to give them a questionnaire. They're going to fill up that questionnaire. And then that questionnaire will actually help you measure the employee engagement. So that is a metrics. So it's nothing but a relation between data points, but it's just a relation between the data points. They will not identify causal relationships or give predictive solutions. Yes, they will help you measure a particular construct, a particular variable, but they will not in any way be able to tell you, does a correlation exist? Is there a cause and effect over here? And definitely they will not be able to predict things for the future because they're unable to identify any kind of relationships. Now, analytics. So when we use these metrics as an input, and then we are actually doing analytics. And HR analytics, when you start implementing it, or when you start using it, is here that you will now be able to identify cause and effect, the causations, that this is a dependent variable and this is the independent variable, right? So you are trying to identify a cause and an effect, right? So the independent variable is the cause, which produces some change, some effect, which is indicated in your response variable, which is also known as your dependent variable. So HR analytics works out causation, and it is also therefore able to give you predictive analysis. So your simple regression, multiple regression that you are using is nothing but a simple predictive model. Because herein what we are doing is we are collecting data from the real world, which is your sample, and we are trying to find out, is there a relationship between the dependent and the independent variable? If there is a relation, how much of an impact the independent variables have on your dependent variable? Now, using this historical data, when you extrapolate your regression line, you are actually trying to predict what can happen in the future. So your regression is a very simple, predictive model that you can have. The data that is used by HR analytics can be from internal sources, from within the HR department, or from external stakeholders. As we said, you know that HR is very much a strategic partner, a business partner. It is not just confined to within the HR department, but it also has to take, other perspective of external stakeholders like the customers, like the investors, like the society at large, like the government agencies, the various licensing agencies, banks, all of that, right? So this data which is used in HR analytics can either be purely from within the HR department, or it can be from external stakeholders as well. HR analytics is strategic in nature. So when we are using HR analytics, we are actually trying to determine how HR can impact the business outcomes positively, right? So that should be the aim of HR analytics. Focus is to develop, to predict the future outcomes, what's going to happen in the future. It also helps you identify patterns in data. So what are the trends? From there, and you will get the different trends that are there. So what are those patterns in, in data? You can make use of, longitudinal data here. So every year you can, measure the employee engagement level of your employees and see what kind of a pattern it is following. Every year, you can measure the attrition patterns in your organization. So all of this is going to come from HR analytics. Some common examples, you can have a whole lot of metrics here, but just some popularly used metrics I have put on the screen just for you to glance through this and get a feel of it. So offer acceptance rate, that is a number of offers accepted by number of offers made. You have the selection ratio, number of hired candidates divided by total candidates, cost per hire, compa ratio, a very, very important metric which is used in comp and ben applications. You have the market index so that you can, compare the average pay rates as compared to what is existing in the market. Are you paying above the market rate? Are you paying at par? Are you paying below? All these metrics will actually help you design your compensation strategy. All these metrics will help you design your talent acquisition strategy. Sourcing channel cost, when you're trying to get talent from different channels, from maybe social media, from campus hiring, from third party, your own HR department is doing it. So which particular channel is giving you the best, optimum results? Again, here you can make use of this metric. Yield ratio, typically when we are doing recruitment, it's a multi-stage process and you have a recruitment pyramid. At every stage of that pyramid, at every layer or at every level of that pyramid, you can calculate the yield ratio to, do a drill down analysis to understand at which stage there is a bottleneck in your recruitment process. Which are the stages which are smooth, which are seamless, where, the process just flows through. And at the same time, also identify any kind of bottlenecks that may be there in your recruitment process. So some examples, of course, as I said, this list is just indicative. You can have a very, very exhaustive list of metrics that you can use in HR. Two important concepts here, lagging and leading indicators. So just this visual that you have on your screen will actually help you understand very clearly as to what is the difference between lagging and leading indicators. So are you watching the road ahead? Are you watching 2019? Or are you watching how 2022 is going to unfold? If that is what you are doing in your organization, you will need leading indicators, right? So if you're looking ahead, then you are talking about leading indicators. But if you're looking in your rear, mirror, so rear mirror is going to show you what is behind you. You have already crossed that. Your car has crossed that, right? So that's 2018, or we can hear, as we are positioned today, we can say this is 2021. So whatever happened in 2021, if you're looking at that, if you're analyzing that, then you're talking about lagging indicators. So the simplest way to understand, what is a lagging indicator and what is a leading indicator is just have this visual in your mind. So if you're looking at the road ahead, you're talking about leading indicators. But if you're looking in the rear view mirror, that's going to give you a back, view. Then that is what is a lagging indicator. So simply put, we can say leading indicators influence future performance, right? So if you're making use of a leading indicator, you will have time to make corrective action. You will have time to do mid-course correction, because it is something in progress. It's a journey in progress. So if you are making use of leading indicators, you can alter, you can monitor these leading indicators to achieve desired outcomes in the future. Lagging, you're going to analyze the past, right? So whatever has happened last year, what was the attrition rate? What was the employee engagement level? What was the employee turnover? What was the sales performance, right? What was the revenue? What was the ROI of the company last year? So you are analyzing past performance. If you're using this, then you're making use of lagging indicators. Now, mind you, both are important. Leading indicators are also important, and lagging indicators are also important. And therefore, when you're doing analytics, it's a good idea to have a combination of leading and lagging indicators. You have to learn from the past. You have to learn from the history. But then, you have to go ahead and manage the organization, keeping the future in mind. As simple as saying, life has to be understood backwards, but it has to be lived forward. So lagging indicators is going to give you that understanding of whatever has happened in the past. The lessons drawn can then be used to correct the future. So a judicious combination of leading and lagging indicators, if you have in your study, if you're using in your project, then that is a situation which is very desirable. So lagging indicators, let us try and understand that with the help of a few examples. So, your weight, your body weight. So if you are, 45 kilos today, you can be very happy about it. If you're 70 kilos, if you're 80 kilos, whatever is your body weight, you have gained that weight. So that's a lagging indicator. What will be the leading indicator corresponding to this? Number of calories you are consuming per day. If you're keeping track of that, then please understand, you find that today I consumed, maybe 40 calories extra. You can act on it. Probably you say, I'm going to spend one more, hour in the gym today, so that I'm able to burn the extra calories, and I'm going to maintain my weight at whatever, 60 kilos or whatever is your target. But there's nothing you can do about your weight. You have already gained it. Okay, so that's a lagging indicator. But if you're keeping track, if the metric that you're using to manage your health is number of calories per day, then that is a leading indicator. If you're talking about employee turnover, so in 2021, the employee turnover was X. It has happened, right? You can't do anything. These people have left you. They've gone. They must have joined your competitor or whatever. They may have retired or whatever they're doing. They've left you. There's nothing you can do about it. So that's a lagging indicator. But if we are going to, keep track of employee engagement index, and we know that employee engagement is a very, very strong predictor of turnover, right? So if you're going to keep track of employee engagement and you feel that the employee engagement is dipping, it's coming down, maybe you can do something as a manager to up the engagement, which in turn will help you control the employee turnover. So if you're using employee engagement index, there is something you can do to achieve a lower turnover in the future. Number of accidents on the shop floor, it has happened. But if our metric is making use of compliance with safety protocols, what was the percentage of compliance with safety protocols? And if you find it has dipped, again, you can tighten up the entire, the process. You can call in the stakeholders and give them, certain certain goals, that this is what has to be achieved. You can give training with respect to all the safety protocols. So if all of this you're going to do, then you can probably bring down the number of accidents on the shop floor in the future. Cost of training initiative, again, you have incurred that, so that's a lagging indicator. But if we are going to measure training effectiveness, then that becomes a leading indicator. So these are some examples probably which will try and help you understand that what is the difference between a lagging indicator and a leading indicator. So lagging indicators, what are the characteristics? It depends on the activity undertaken in the past, right? And they measure the result of this activity. Okay, so the employee turnover, which has happened. So because of n reasons, these people left. So what is the result of that? That is the employee turnover of 2021, the attrition rate of 2021, right? The lagging term here, why are we calling it lagging indicators? What does this word lagging mean over here? It reflects the delay in action and change in the final outcome. So fine, something has happened. You will learn from it and probably implement things this year, and the effect of those changes you're going to see in the future. So there is a lag between action that you're going to take and the change that action is going to bring about. That is why we call these as lagging indicators. Common examples in the HR context: ROI of training, cost of recruitment, employee satisfaction of the previous year, right? Revenue per employee, rate of unemployment in the country. So these are some more examples from the HR domain with respect to lagging indicators. Leading indicators, what are their characteristics? Firstly, leading indicators are process measures. So you have a process. The process is in progress. And as it is in progress, you are measuring, right? So the leading indicators help to measure the incremental progress being made towards achieving the key HR outcome. So it is something which is in progress, right? It's work in progress. As the process is happening, as the process is unfolding, you are measuring the incremental changes that are happening, and these changes can then be monitored, can be impacted, can be intervened to achieve better HR outcomes, right? So there is less of a delay between action and change in the outcomes. That's why, it happens fast. It can even happen in real time, right? So it's telling you what is happening now, what is currently unfolding, and not what happened in 2021. As we sit here in January 2022, what is happening in your organization? This is what the leading indicator is going to communicate to you. Very important. Why we lay so much of stress on leading indicators is because they provide early warning, right? So supposing, the employee engagement level has dipped for this month, right? So it's going to provide you a very early warning sign. Something is wrong. And it's so in good time, you will have reactionary time to act on it and correct the problem which is there in the organization. Now, leading KPIs, that's key performance indicators. The key, indicators, they are known as, key performance indicators. Not all indicators are that critical or that important. The most critical, the most important of the indicators we would term under KPIs. So they measure the input that should be introduced to achieve better results. We can monitor the leading indicators to make to influence the outcomes. And this makes them very, very useful, right? So this is the single most important reason why we want to use leading indicators, is because they tell you that right now you can take corrective action to achieve better outcomes in the future. Common example: percentage decrease in attrition, right? So 2021 had an attrition in January of this much percent. What's the decrease? Has it decreased by 10%? Good. Has it increased by 10%? Then there is a problem. You need to look into it. You need to understand what managerial intervention is required. Do we need to change our HR processes and practices? Is there a problem in the work culture? Is there a problem with leadership? What is the reason for that increase in attrition? Why it has increased? Percentage increase in employee engagement, most welcome, right? So keep doing what you're doing, perhaps reinforce what you're doing. Is there an improvement in ranking of employer of choice? Has our employer branding improved, or has our rank gone up as far as this survey is concerned, or has it gone down, or is it constant? What is it? Percentage improvement in employer branding index. So again, in the HR context, these are some leading indicators which you can look at in your organization. Right. Resignations. Very, very, troublesome for the people from the HR fraternity. How to handle resignations, right? Because when people resign, resignations are associated with a lot of cost. Cost can be direct cost can be indirect cost. A lot of these costs are, tangible cost. A lot of these costs are also intangible cost, right? So when people resign, again, you have to fill the vacancy. So you have to go back, advertise, recruit, select, go through that entire induction training. You have to give lead time to the employee to get acclimatized to the culture and start performing, right? So a whole lot of cost associated there. The intangible costs are more, in the nature of, the workflows are disrupted when people leave, because people have, particularly where you have sequential dependence of work, and somebody leaves, that sequence is disrupted, and people may find it difficult to get the work done. So, and there may be, a decrease in the morale and motivation of the people. So these are some of the intangible costs which are associated with resignation. Now, if you look in today's times, we are a global village. So people are very ready to move across geographical boundaries for their work, for their careers, and all of that. And there are certain industries which are more impacted by this than others. So they are fighting a war for talent because people have opportunities. There is, inter-country mobility is there because of globalization. The competitor is ready to lure, your human capital. And all of this has put up tremendous challenge and a lot of pressure on the HR professionals, how to retain talent, and not only retain, how to acquire talent which is of quality and all of that. So there is out there a war for talent. So in this context, next what I want to take up with you all is a particular case scenario which comes from an organization which belongs to the IT industry. And before I go further, I would want to emphasize that resignations when they come from performing employees are very, very worrisome, because here you're going to lose a lot of talent, and the double whammy is your competitor is going to get a very trained person who's going to add a lot of value to their organization. So you are going to use human capital, and this human capital is going to go and benefit some other organization. So it becomes really worrisome. So your regrettable losses, the losses that you're going to regret in terms of losing performing employees can give your HR sleepless nights. So this is a case scenario, and here the project that was that, can you predict the resignation intent of my employees? So look here, we're trying to use predictive modeling. So proactively we will try to identify those employees who may have an intention to resign, right? So you see, resignation is not just an overnight decision. There are antecedents which lead to this decision. So a lot of things will be happening over a period of time, basis which the employee is going to decide whether the person wants to tender the resignation or would want to continue in the current organization. So this project was all about finding out whether we can arrive at a predictive model which will predict, yes, this employee or employees who has who's exhibiting this kind of characteristics or behavior is very, very likely to resign. So we are also going to talk here, in terms of probabilities. So the probability of resigning is high, low. That is what this model is going to try and do. So small case scenario here, just to set the context. So Graphics Private Limited is a computer animation company. And this company specializes in making animation programs for media companies. So you have the industry there. The employees are required to sit long hours and use all their creativity to do their work, right? So they have to be people who are extremely creative. Now, also understand that creativity doesn't, come if people are, have to work in a very, very structured environment, in silos or in compartments, or where there is no freedom to think freely. So here you have these employees, they have to sit long hours and they have to use all their creativity to make those very wonderful animations that they make. This work demands, or rather the work demands can be consuming, as the industry follows religious compliance to timelines. So these companies have very strict deadlines. The projects have to be delivered within the deadline. Otherwise, there are a whole lot of legal implications that the company may have to face. So in fact, graphics has differentiated itself in the very competitive industry as a company that never violates its project delivery deadlines. So they are always able to live up to the project delivery deadlines. So this is something which is very, very critical. This is the source of their, competitive advantage when it comes to warding off competition in that industry. With Industry 4.0 revolution, the company is experiencing unprecedented growth, and it is sweating its assets to keep pace with demand of its customers. So it's getting a lot of orders, it's getting a lot of work, right? But at the same time, it is very stretched. Also, it has to deliver within the deadlines. So amidst the VUCA, that is volatility, uncertainty, complexity, ambiguity, business environment it is grappling with, the company is increasingly depending on its human resources to help them tide over the challenge created by the business ecosystem, right? So it has its human capital, which it is trying to leverage to handle this very tough scenario in which it is placed. The IT industry employs a knowledge worker whose skills, competencies, and attitude comprise the intellectual capital of the organization, unlike other resources. With increased globalization, talent mobility has increased, and graphics today is struggling to cope with the loss of talent. So human capital, the most important asset it has, it is the source of competitive advantage, but because of the mobility, the talent mobility that is there, it is struggling to keep this human capital together and sustain its competitive advantage. Increased employment opportunities, skill demand, and the competitors' luring tactics, all of these are contributing to employee turnover. The increasing employee resignations at the company are having costly outcomes for the organization. So in this scenario, the company asked the HR department to understand the main reasons why employees are resigning. What are those factors which are prompting employees to resign? The CEO asked the HR department to come up with a model to predict the intent to resign. And such a model will identify the intent of resigning from and the job, and the company can take proactive measures to reverse the decision, particularly in the case where the employee is a performing employee. So that was the whole rationale, that if you have a predictive model which can tell you in advance that so-and-so employee is contemplating resignation from the company, from the job, and if the employee is a performing employee, if the employee has got certain key competencies that your organization needs, then you as a manager need to intervene and see how that decision can be reversed. So this is the whole case scenario. This is the context in which this is further analyzed. So before that, Yeah, so first of all, the how the HR department went about doing this was they circulated a questionnaire to understand what are the factors which people consider when deciding to resign or not to resign, right? So a questionnaire was circulated to these people. Now, further to this, an EFA exploratory factor analysis was done using the principal component method to identify which of these items on the questionnaire can be grouped together, right? Because many of these questions or items, as we call them in the questionnaire, could be talking about the same factor. So EFA was done to understand which of these factors can be grouped into a smaller number of factors rather than having those large number of items in the questionnaire. So in this context, the KMO test, which is a measure of sampling adequacy, that was found to be 0.88. This analysis was done in SPSS. You all can try your hand at it. So in fact, you can use any tool, but I would be demonstrating this with the help of SPSS. So the KMO was found to be 0.88. And the second measure that was used was Bartlett's test of severity. I would request you to please mute yourself. Right. So the two measures that were first of all considered was the KMO, which is a measure of sampling adequacy, and Bartlett's test of sphericity. This was found to be significant. Now, when these things were found, KMO 0.88, and see, it should be above 0.7 to be acceptable. 0.88 is considered to be good. And the Bartlett's test was found to be significant, meaning that there is a correlation between the various items. So this paved the way for doing your EFA. Okay, so we could proceed with the EFA to group the closely correlated factors together. Communalities using the PCA for all the items was found to be above 0.5, which meant that they were minimum explaining 50% of the variance, and most of the items showed communalities which were above 0.6. Varimax rotation was used, and total of 5 factors could be extracted, and these 5 factors cumulatively explained about 68.25% of the total variance in the outcome variable, in the response variable. So here you have a scree plot. This is again, a visual depiction. Very clearly, it shows you before you get the elbow, before the curve flattens out, you can identify 5 distinct factors. So scree plot is nothing but a plot of the components or the items that you have used. So 24 different items were used in the questionnaire. That's on the x-axis, and on the y-axis you have the eigenvalues, right? So on the y-axis, the eigenvalues are there, and as you can clearly see that before the elbow is reached, before the curve starts flattening out, you have a clear 5 factors that are extracted. After the EFA, just to confirm whether these factors were, we did a CFA. So this was done using AMOS, and here again, the results that we got were again telling us that yes, these factors are fine and we can proceed. The reliability, which is the consistency of the scales. So the 5 factors that were identified, we have to name those factors. So the 5 factors that were identified were named as employee engagement, perceived organizational support, POS, salary, tenure, and absenteeism. So these 5 factors emerged as factors which employees would consider when they were about to resign or when they would not want to resign. So this is what came out, after your EFA, CFA. The Cronbach alpha, which is a measure of the reliability of these scales. So each of these was on a 7-point Likert scale. So the reliability came out to be, you know, as you can see, all are above 0.8, which is good enough. You know, it should be above 0.7. So all of these are above 0.8, as you can see. So we can, you know, safely say that all these scales that we have used have reliability, which is given, you know, by Cronbach alpha. The number of items, of course, are measured. That is the number of questions used for each of the scales. Next, we have to find out the convergent and discriminant validity. So what is validity? Validity simply means that the scales that you're using, the measurement tool that you're using is actually measuring what you want it to measure. So for example, it is actually measuring employee engagement and not employee satisfaction and not employee commitment, but it is actually measuring employee engagement. The scale for POS, that is perceived organizational support, is actually measuring POS and not some other construct, right? So that is what we try to establish here. So two types of validity we will establish here. One is the convergent validity and the other is the discriminant validity. Now the condition for convergent validity is the CR, that is the composite reliability. Now, this analysis you can do in AMOS. Also, you know, you can do this. There is a James Gaskin macro which is available. So if you go to Google and you type, you know, James Gaskin, you know, so you get Stats Wiki. That's the name of the file. It's a macro file. You can download it. It is freely available to you. And then all you need to do is from your AMOS, you just need to copy paste into that and it will give you this table. It does all the computation for you and you get this ready-made table here with all these calculations.
Madam, can you please repeat James Gaskin?
Yes, James Gaskin macro.
Macro.
Yeah, you will get it by the name of Stats Wiki. Stats Wiki. It is freely downloadable. It is much like an Excel sheet which has got macros embedded into it, and it gives you clear instructions that paste the correlations in cell A1, paste the R square values in so on. All you have to do is just follow these instructions and very nicely it will give you this output.
Thank you, madam.
Right. So the convergent validity has to be above 0.8. And as we can see, for all our 5 constructs, the 5 factors that we have considered which impact the decision to resign or not resign, for all of them, the CR is above 0.8. So convergent validity with the help of composite reliability was established. And AVE is average variance extracted. Right? Average variance extracted. Now the average variance extracted should be greater than 0.5. Okay. And for all our 5 constructs, we can see from the table, it is greater than 0.5. So both the conditions are fulfilled and we can say that we have achieved convergent validity. The next is discriminant validity. Now what is the meaning of discriminant validity? You see, we try to establish that, you know, with the help of constructs which are very dissimilar. See, constructs which are similar will have a higher correlation, but constructs which are just not related to each other should have a very, very low correlation. So discriminant validity, the logic behind using discriminant validity is we try and establish that the correlations between 2 constructs which are very different, which are very unlike, is very, very low. So that is what we try to establish with the help of discriminant validity. Now, please note that discriminant validity is checked with the help of what is known as Fornell-Lacker criteria. Right? Now, this Fornell-Lacker criteria talks about 2 things. One, it says the average variance extracted should be greater than maximum shared variance, MSV, right? So if you look at the second column, AVE should be greater than the third column, that is MSV, and which it is, right? So our first condition is fulfilled as far as discriminant validity is concerned. AVE should be greater than MSV. What is MSV? Maximum shared variance. And the second criteria for discriminant validity is the square root of AVE, right, should be greater than the correlation between the constructs. I'll repeat, the square root of AVE should be greater than the correlation between the different constructs, right? So if you go ahead, see, I have put some of these points in some of these numbers in bold. So for example, in employee engagement, 0.794. This is the square root of AVE. You can quickly do a calculation. If you take the square root of 0.631, you will get this particular value. So this is your square root of AVE. Now look at this square root of AVE. It should be greater than the correlation between POS and employee engagement, which is nothing but 0.39, between salary and employee engagement, which is nothing but 0.248, between tenure and employee engagement, which is nothing but 0.398, between absenteeism and employee engagement, which is 0.616, right? So satisfied. This way you check for all the 5 constructs, you will find that this condition is also satisfied. The square root of AVE is greater than the correlation between the construct. So because we got this kind of a table, because we got this kind of results, we can say that yes, we have established convergent and discriminant validity. Now the next thing that comes is, what about the model fit? Yes, our scales are fine, our measuring instrument is fine, but what about the model fit? Does it fit the data properly? Does it fit it good enough? What is it? So here we can again make use of various model fit indices. Some of them I've put here in the lower table, the smaller table there. So Cmin by DF, it's 3.42. It should generally be less than 4 to be considered as a good fit. GFI, goodness of fit index, should be greater than 0.8. So we've got 0.858. AGFI again should be greater than 0.8. RMSEA is a badness of fit index, right? So the smaller it is, the better is your model. So whereas GFI, AGFI are goodness of fit index, your RMSEA is badness of fit index. So the smaller the value, the better it is. And if you look up literature, you will find, Black and Hare, the citation is there, which says that RMSEA less than 0.08 are acceptable. So we are just, just within that that limit that has been given by Hare and Black, right? So RMSEA here is 0.077, which is badness of fit index, and GFI and AGFI, which is goodness of fit index, and adjusted goodness of fit index, both are above 0.8. So with this particular, we can say that there's no problem with the measuring instruments, the measuring scales that we have used. Now coming to the model, so remember we have to come up with a predictive model, predicting what? The intent to resign. Okay. So I'll just give you a brief of what a logistic model is, just in very, very brief. I'll try and explain here. So if P is the probability of event happening, so obviously, probabilities have to add up to 1 if you sum it up. So probability of event not happening would be 1 minus P, right? And then let's start from the bottom. The probability is given by E raised to A plus BX, where A is the intercept, B is the coefficient, X is your predictor, right? Some people call it as independent variable. Some people call it as explanatory variable. We will call it as predictor, right? And so it is, the probability is given by E raised to A plus BX divided by 1 plus E raised to A plus BX. Now from where we've got it, you can just go back and refer to your statistics books. So that is probability. Now, if we want to take the ratio of the event happening to the event not happening, right? So the probability of the event happening is P. Probability of the event not happening is 1 minus p. If you substitute these values of p and 1 minus p, you will end up having e raised to a plus bx. Okay. Now this ratio of the probability of event happening to the probability of event not happening is known as the odds ratio. Now, when we take the log of this, we transform this to get a logarithmic, function. Because if you see, this is a function which is a division function, p divided by 1 minus p, or you can say p into 1 upon 1 minus p. Okay, but if you take the log of this, if you take the log of both of the sides, so log of odds ratio will be equal to log of p upon 1 minus p. And when you actually work it out, you will get this as a plus bx. Now, when you take the log, this is known as logit or logistic function, right? Now, I've kept this simple here because I have considered only one predictor here, one independent variable, that is x. But nothing to worry. If you have more, you just keep on adding. So it will become a plus b, b1 x1 plus b2 x2 plus b3 x3, so on. As many number of predictors you have in the equation, that is all that you need to do. So this is the logistic model that we will try to use, in arriving at the predictive model. Now, in our study, we are going to consider employee resigning as the reference category. And we are going to use, dummy coding here. So probability of employee resigning, please understand, we will be talking only in terms of probability. So probability of employee resigning will be taken as a reference category, and we are going to code it as 0. Opposite of this is probability of employee not resigning, and we are going to code it as 1. So please remember this. It's important because as we go forward, in order to understand what we are doing, you will have to bear this in mind, that the probability of employee resigning will be treated as the reference category and coded as 0. The probability of employee not resigning will be treated as the target category, and that will be coded as 1. In our study, we have identified through EFA, confirmed through CFA, that there are 5 factors which employees consider when taking this decision to resign. And what are those 5 factors? They are employee engagement, perceived organizational support, tenure with the current organization, salary, and absenteeism. Right? These are the 5 factors. And from where did I get this? Actually, when we were doing the literature review, this was found in the literature review, tested through EFA, CFA, and these are the 5. So we are going to build a predictive model using these 5 predictors. Right?
Madam, one question here.
Yeah.
Madam, you said these 5 factors, but there may be a lot of statements which you would have in the questionnaire, madam.
Right. So
you mentioned 7-point Likert scale, but how many statements were there?
Right. So we had used 24 statements. So I'll just take you back, to this slide here. See, this is the scree plot. What is the scree plot? Yeah. The component number of items on the questionnaire. They were 24. And when we subjected it to the EFA, we were able to extract using Varimax 5 of these. We were able to combine. See, you got 5, and looking at the items, then we named them as engagement, as salary, as absenteeism, so on and so forth.
Right, madam.
Right. So with this, now I'll try and, actually demonstrate. It's very easy in SPSS. It's a wonderful software. It does everything for you. Only thing is that you need to have the conceptualization in your mind, that clarity has to be there, and rest SPSS is going to do everything for you. So I'll share that SPSS file with you. Just give me a minute. Right. So please confirm to me that you can see my SPSS file.
Yes, that's right.
Right. So here, look here. Now resign. Look at the way the data has been entered. It is either zeros or it is 1, right? Now remember, what was 0? Resign. This is our reference category, which I told you just now. And what is the meaning of 1? 1 means not resign. Correct? So that's how the data is entered here. And then after that, you can, see the predictors. You can also see, employee engagement score, performance score. It was, initially considered, but later dropped because of some reason. So we'll not be considering it in our model today. Then you have POS, which will be considered, absenteeism, which will be considered, salary, which will be considered, promotion, which will not be considered. And I'll tell you a little later why I'm not considering promotion. I had considered promotion, but I'll tell you, after I have built the model, why we are not considering promotion. And tenure. Forget about pre-1 and pre-2, that those are saved calculated values. So this is how the, the Excel, this is how the SPSS sheet is going to look like. So again, I'll just reiterate, our dependent variable is categorical in nature, that is resign, having a dichotomous outcome, where 0 means resign, 1 means not resign. So important for us to understand this. Our response variable, our outcome variable, our dependent variable is resign, which is a probability whether the person will resign, 0, or not resign, that is 1. We are going to use 5 predictors, namely employee engagement, POS, absenteeism, salary, tenure. All of these are metric in nature, right? Whereas resign is categorical dichotomous. But all of the predictors are measured on a continuous scale, on an interval scale. So this is the data. This is what the data is going to look like. Now, if I go to analyze, I need to go to regression here. I need to go to binary logistic. Remember, my outcome variable, my dependent variable has got only 2 dichotomous outcomes, resign or not resign. So I'm going to click on binary logistic here, right? So yeah, let me just reset this so I can show it to you again. Right. So resign, I'm going to put here. And engagement, POS, absenteeism, salary, tenure, I'm going to put in the covariates. Categorical, I'm not using any categorical variable. As you can see, all of these are scale variables, so I don't need to do anything out here. Then I go to options. I'll try and click the classification plots here. I need the constant in my predictor model. I say continue here. And then all I do is OK. Now, the sample size was 429. This is the output of the SPSS thing. If you see again here, dependent variable encoding, that is resign is 0 and not resign is 1. That is what we were trying to say. And this has come in your output also. This is the block 0, where the variables are not entered. None of the predictors are entered here. It is only an intercept model, intercept only model. So you can just go through this, not that much important. And then in the next block, the method for entering all the predictors is all of the predictors have been entered together. And as you can see over here, this is block 1. So omnibus test. Now, omnibus test is found to be significant, as you can see. Now, what is the meaning of omnibus test? Omnibus test tells you that is this model better than the base model? And what is the base model? The model which does not have any predictors. It is an intercept only model. So this is what you should get. Otherwise, it simply means that the predictors that you have chosen are not relevant, right? So you should get an omnibus test which is significant, and which you can see here it is. So it tells us that our predictors are significantly contributing in explaining the outcome variable. If you look at the model summary, now -2 log likelihood is again a badness of fit index. We'll not talk so much about it, but let us talk about Cox and Snell R-square and Nagelkirk R-square. Now, these are, they are known as pseudo R-square. and you can draw the analogy with the R-square that you have in multiple linear regression. This is logistic regression, but when you do a multiple linear regression, you get something which is known as R-square, right? So these are analogous to that R-square. And it simply means that, you know, the model fit is going to vary somewhere between 60.6 to 80.8. Right. So again, we can say, you know, the model fit of our logistic model is good. And these are known as global model fit indices. So Cox-Snell R-square and Nagelkerke R-square, also known as pseudo R-square. That is what, you know, is telling us that, you know, it's reasonably good. We can accept this model. The model fit is decent. Not very high, but it is decent. Next is our classification table. And in the classification table, you know, you get these various percentages. Overall accuracy of our model is coming out to be 91.8, right? And the same thing can be understood with the help of this diagram that you have here. So this diagram, you know, it should always be bipolar. Bipolar meaning, you know, because we are deciding between two outcomes, resign or not resign. As you can see, most of the values are at the two ends of the diagram. That means resign has been classified correctly as resign and not resign has been classified correctly as not resign. Whereas there are a few cases, you know, where a resign has been misclassified as not resign and vice versa. So, you know, those in between that you can see, you know, RR stands for resign, N stands for not resign. So a few of these cases have been misclassified, but then that's okay. When you take data from the real world, you cannot have, you know, 100% accuracy, but we still have a fairly good accuracy that's been given by this. So this is just a depiction. This is just a visual depiction of you know, this classification table. Very, very important is this table here. This is the variables in the equation. All right. Now, these variables, if you look at B, they tell you that when the predictor is changed by 1 unit, the log odds. Now, it's not a direct relationship. It's not probability is going to change. No, the log of odds. What is odds? Ratio of probability to ratio of the probability of event happening to probability of event not happening. The log of that is going to change by 0.035, or we can say 3.5%. So in this case, I'll try and explain this again to you. In this case, if engagement score increases by 1 unit, the log odds will change by 3.5%. That is what it means. If POS, and they are positive, so we are talking about increase. If POS changes by 1 unit, the log odds is the probability of log odds is going to change by 5.7%. If absenteeism increases by 1 unit, now look here, it's got a negative sign, means the log odds is going to actually decrease. Okay, salary positive, it will increase. Tenure positive, it will increase by 30.3%. If you can see, tenure is having the most significant impact, 30.3%. You know, the intent to stay back is going to increase. All right. One more thing which I want to draw your attention to is Wald's ratio here. Right? What is the meaning of Wald's ratio? Wald's ratio tells you whether the individual predictor is contributing significantly or not in explaining the outcome. So as you can see, all the 5 predictors have got a significance value which is less than 0.05. So each of these 5 is individually contributing in explaining the intent to resign. The last column, exponential beta, is nothing but your odds. And this is a multiplicative increase. So if employee engagement score increases by 1 unit, the log odds is going to, is going to change by 1.036. Now, when B is positive, exponential beta will always be more than 1. When B is negative, exponential beta will always be less than 1, as you can see here. So for absenteeism, where B is negative, you will find that exponential beta is also less than 1.811. Whereas all other predictors have got a positive B, so exponential beta is also positive. So loosely speaking, mind you, it's not very statistically correct to say that, but loosely speaking, we can say that if our B is positive, the probability of the event of the target category will increase. And what is our target category? Not resign. So if engagement score increases, the probability of not resigning increases. If POS increases, probability of not resigning increases. If absenteeism increases, probability of not resigning actually decreases. That means the probability of resigning increases. Okay, so absenteeism is the warning bell for us. Same logic goes for salary and tenure. When they increase, the probability of the employee staying with the organization, not tendering the resignation, increases.
Madam, one question.
Yeah.
That thing. Yeah. Madam, this exponential B and the values for it, can it be ranked? Say, for example, tenure should be 1 because it is the highest value.
No. That's what I said. We don't have a linear relationship here. Remember, we are using a logarithmic transformation. So it's not a linear kind of a thing that you can rank, because tenure has got the highest B.
Yeah.
The exponential beta can be ranked. Exponential beta, like I said, is log. Log meaning what? It is P upon 1 minus P. So it is not a linear, relationship.
Got it.
Yeah.
Right. Yeah, ma'am, but even though it is not linear, but the probability of falling to a category 1 increases with a higher odd, right?
Correct. So, when your exponential beta is greater than 1, if it is 1 means there is no change in probability, right? But if it is greater than 1 means when the predictor increases by 1 unit, the probability of the target category, and what was our target category here? Not resign, increases. Right? And by the same logic, absenteeism being negative, so whenever you get a B which is negative, you will get an exponential beta which will be less than 1. So when you multiply by a decimal, right, the value comes down. The value of the original value, when you multiply anything by a decimal, the original value is going to come down. Multiply 5 by 0.81, it will be less than 5. Whereas if you multiply 5 by 1 point something, whatever thing, the value is going to go up. So that's the understanding. Right? So this way I'll take you now how to develop the model. So this, if you understood this analysis, let me take you back to my PPT. Please confirm to me. You can see my PPT.
Yes, madam.
Okay. So this is nothing but the same, I've copy pasted here. So I'll just go through this omnibus test being significant. This is your R squared, the global model fit indices. This is the classification table. This is the same thing. Yeah. So coming here, now how do we write the logistic equation? So logistic equation, the LHS is log, right, of probability of not resigning divided by probability of resigning, that is P upon 1 minus P. And that is equal to the constant. Look at the constant. It is minus 10.845, right? And then, just like you do in multiple regression, same logic is here. So you take the B value of employee engagement 0.035 into engagement plus 0.057 into POS minus 0.210 into absenteeism plus 0.075 into salary plus 0.303 into tenure. The important thing to bear in mind here, and I repeat myself, is that this RHS that you get is not related to the probability, but it is related to the log of the odds ratio. That is what is important to bear in mind. This is a logistic model. So this, is your logit or logistic model. So this is what is important to bear in mind. Now, basis this.
What was the intention behind taking the logistic regression actually in this calculation?
Taking the largest?
No, not largest. The logistic regression they were considered,
Correct.
right? Why they had to arrive only to logistic, and here if you are noticing, right, they're not just taking the probability alone, they're taking the log of the probability.
Correct.
So why this is happening basically?
Yes, I'll tell you.
Yeah.
So firstly, why the choice of a logistic model? See, we have got two dichotomous outcomes. Resign, not resign. Dead, alive. Pass, fail. Placed, not placed. Right? So when you have these kind of dichotomous outcomes, logistic model is perfectly the optimum model to use. Now, why we are taking a log and not directly? Because, if you go back here, see, when you take the logit, that is the log odds, that is log of P upon 1 minus P. Actually, what are you getting? You are getting an additive equation, which you get in ML multiple linear regression, A plus BX. So we have changed, something which was of a multiplicative nature to something which is of an additive nature, which is very similar to what you are using in your multiple regression. What is the equation for multiple regression? A plus B1 x1 plus B2 x2 plus B3 x3, right? So if by transforming using the logarithmic function, we have converted, an otherwise function that is probability. Look at probability. What is it? E raised to A plus Bx divided by 1 plus E raised to, E raised to A plus Bx and so on and so forth. That by transforming it using a logarithmic function, we have converted to something which is additive in nature, something which is A plus B1 x1 plus B2 x2.
That exponential is there, right? It is not complex exponential, I guess. It's just numbers you'll be getting, or it's a complex exponential.
It is E raised to, that's the exponential.
So that A plus Bx is there, right? E raised to A plus Bx. So you are considering the numbers alone there, or including the complex exponential?
No, you will have to multiply. You'll have to use the E function there.
Okay.
Yeah. I think I'm a little behind time, but quickly, yeah. So based on this, what do we say? We say those employees who have higher engagement levels, higher POS, they have spent more time with the organization, they have higher salaries, they will exhibit lesser intent to resign. And those who are showing high levels of absenteeism, that's a warning bell. Organizations should know something is wrong. This person is contemplating resigning. And if he's your performing employee, you don't want to lose him, please intervene and do something about it. So these were the recommendations that were given by the HR department. Based on this logistic model, so to arrest regrettable losses. Now, quickly, I would want to, once again, I told you that I had not included, promotions. So why I had not included promotions, I'll just tell you why. So I go to analyze, I'll repeat the same exercise quickly. So I go to regression, binary logistic. Now everything is there. Now I include promotion also. Please understand, promotion is a categorical variable. People who have got promotion in the last 3 years, yes or no. So it's a this thing. Now I have now a mix of continuous and categorical variables. So I need to tell SPSS that, this variable is categorical. So I go to categorical here, and so promotion, I have to tell them that this is a categorical variable. I say continue, rest of the things all same. I say okay. Now look here, everything you're going to get same. But if you go to the last, table here, yeah, this one, variables in the equation. Now you see promotion has come here, but look at the significance level. Significance level is 0.741, meaning it is not significant, right? So that is telling you that it is not significantly explaining your dependent variable. Okay, look at the Waltz ratio also. It's very, very small. It's in decimals. So this also is telling us that promotion per se, individually, is not contributing significantly in impacting the resignation decision. And hence, in the model which I just demonstrated to you, I had dropped promotion and had gone ahead by using only 5 of the predictors. Right, so I hope making sense.
Madam, I just want one clarification in my, I have one doubt. How you measure this engagement score and promotion score? Is it directly taken from output of EFA or you measure?
No. Survey, as I mentioned, a survey questionnaire was designed on using 7-point Likert scale, where there were 8 items that were measuring the engagement level of the employee.
And it's an average or summation of all that 8 items?
Summation.
Okay.
Right. See, average and all is okay if you find that there are a lot of missing data. People have not filled your questionnaires completely. There's a lot of missing data. Then it's better to take the average. But if that is not the problem in your data, then you can as well go ahead and use summation.
And you use an original file and not the variables which comes after EFA or the factors which comes after EFA.
No, you use what comes after EFA, no?
Okay.
Yeah. So the outcome of EFA, see, EFA is only going to tell you that, these 4 items should be considered together. Now, by reading those items and by having the subject knowledge, the domain knowledge, you will give it a name. So I would know that, these 4 questions, these 4 items are related to what? Employee engagement. So I called that factor as employee engagement. I will call, the next factor, maybe it has got 5 items as POS, so on and so forth. So that is the outcome that you have to do after you have done your EFA. EFA is only going to tell you these 4 should be grouped together, these 5 should be grouped together, these 3 should be grouped together. Now you have to use your domain knowledge to give it those names. So that naming thing has to be done by the researcher.
Yeah, the same thing, madam. This 24 statements into 5 factors, like what you told.
Yeah.
And the scores is prepared after grouping that 4.
Absolutely. The composite score is taken. So employee engagement, I had, if I remember correctly, I had 8 items. So when the scores for all those 8 items were added together, I got the score. Let's say for me, if I'm one of the respondents, that will be my score for employee engagement. Likewise for you, that will be your score of employee engagement level.
Madam, one question here.
Yeah.
Madam, you did it through regression. We can also do it through factor analysis.
Factor analysis you can do, but to arrive at a predictive model, you will have to make use of logistic.
Yeah, so that's the only differentiation. Otherwise, madam, this grouping into those variables, those statements into the variables can also be done through factor analysis.
Yes, but then that's a technique that gives you the grouping, but the ability to predict will not come from there. For that, you will have to go for logistic regression only.
As per my understanding, it is question is very simple. See, if you are resigning, on what factor you are resigning? If you are staying, what is the reason? So only yes or no. So through that metrics, you are giving, okay, these are the metrics which employee is engaged or employee is disengaged over, right?
Correct. So if you have, Mr. A in your organization who has an employee engagement score of, let us say, for example, 40. who have a POS score of 30, who has a salary in a particular range, who has absenteeism rate of so much. By putting these values in this equation, which equation? This equation, you will be able to find out with probability whether the person will resign or not resign. So you're trying to predict if a person has these levels on these 5 factors, then what's the probability? Will this person stay with me or this person is thinking about resigning? That's how you're trying to predict. Right?
Yes.
Okay. So just give me a minute, just a minute, please. So now I would want to sort of take you through qualitative data analytics and just try to give you a feel as to how this can be used in the HR domain. So why this is important is because if you look around, most of the data around us is in qualitative form, right? Quantitative data is just the tip of the iceberg, right? This is what we can see. But the way we talk, the way we communicate, the way we write, the way we respond on social media, the kind of stories you put on Instagram, a lot of these documents which are there, all of this is qualitative data. So we are living, amidst mountains and mountains of qualitative data. And quantitative is just a very small part of it, just the tip of the iceberg. Qualitative data, what is it about? It's about emotions. It's about perception of people. It's about how they feel. What is their mood? Are they happy? Are they sad? Are they agitated? Are they delighted? So it's about emotions. It's about perception of people. Why it is important? If you know this, if you know what people are thinking, about what people are feeling, this has an impact on their decisions. So if you know that, if you're able to analyze that, definitely you can take better business decisions. So I'll just, I know I'm a little, hard pressed for time. So I'll just take you a little fast on this and try to come to the example which I want to share with you. So in this context, we do what is known as text mining. So when you have data in the textual format, how do you try to dig out information from there? How do you try to understand what that text contains? And here we are talking about big data again, or at least we are talking about data which is very, very large. And hence, you cannot explore or you cannot analyze this data manually. You're going to need software. So here again, you have got various text mining, text analytics, these technologies which will come to your help. Some of these, of course, are your NLP, natural language processing, knowledge discovery, data mining, information retrieval, statistics, and all of that. Process, if you see, you can start with pre-processing. You need to clean your data. You need to remove your missing data. So that is pre-processing. Then you may be required to transform that data. So you can code that data. You can use certain nodes for coding of the data. Then what is it that you want to analyze on? Then data mining is discovering patterns or trends or themes in your data. So that is data mining. Try to evaluate this and see how you can apply. So this is the cycle of text mining as you have it. Advantages, of course, are many. So, it has enabled e-commerce company to do personalized marketing. So if you ever wondered why when you open Flipkart and, it starts putting up sports shoes to you, because in the past you would have, if not bought, surfed for sports shoes. So it has recorded all of that and it is doing the text mining. And probably it's also visited your Facebook account where you have flaunted your new sports shoes. And from all of that, it has actually created a personality clone for you, a psychological clone for you. What do you like? What you don't like? What do you aspire for? and all of that. So that comes from the various text mining that these e-commerce companies do. Government agencies for classifying threats, various criminal activities. So that's how, the internet traffic is monitored. And before, a terrorist attack, these people say that there are patterns to the internet traffic. And that can be used for predicting that, something is being planned and something untoward may happen. Better customer relationship and to better understand the customer. Disadvantages are, security of your personal data, privacy of your personal data, your data getting stolen and being sold by companies today. So Facebook has sold, your data, the user's data to Apple and to, a lot of these companies, and made huge money out of it, but it's your data, right? So, you would want to wonder, who is Facebook to be selling my data without my consent? So these are some of the disadvantages of text analytics. Now, when we do text analytics, there are certain terms that we need to understand. One is known as stop words. So please understand, if you have a document and you are subjecting it to text analytics, this document will have a lot of words which don't add much value by themselves. But if you include them in your analysis, they will clutter your analysis. So for example, I, is, me, my, myself, we, ours, and all of that. So see, is, for example, doesn't convey any meaning by itself. And the number of times is would be used in a paragraph would be very, very high. So if you don't remove these words and you try to analyze your text, these words are going to clutter. They're going to overshadow what the text is talking about, right? What the text is talking about. So what do we do is, when we go in for text analytics, we identify these are the stop words and we don't want to include them in our analysis. So in English dictionary, these are some of the stop words, that you can use and say that we don't want these stop words. Please don't use them when doing the text analytics. Likewise, another thing is stemmings. What is the meaning of stemming? For example, you have a word connect, connected, connection, connections, connect, all means the same thing. So if you say we don't want, we only want the root, the lemma, we only want connect, count it as one, right? Don't count connected as something different than connect. Don't count connection as something different than connect. All of these count as the same word, that is connect, that is the root word, or which is known as lemma. So this is known as stemming. When you do this, when you identify, we don't want the stop words, please only identify the root word. Then what you get is known as BOW. BOW standing for bag of words. So in that document, all this, is, the, me, my, myself would be removed. The lemma only will be used, and all of these words in that document would now be put into what is known as a bag of words. And now these will be analyzed when you're going to do text analytics, right? So three things we talked about. We talked about stop words, we talked about lemma, and then finally we arrived at the bag of words. Now this is what will be subjected for analysis. I'll just skip this for the moment and maybe come back to this later. Yeah, so sentiment analysis. Now, when you're doing text analytics, it will try to identify what is the sentiment in that, right? So when we say sentiment, meaning what are the emotions that are being expressed? Are they positive? Are they negative? Or are they just neutral? So that is what sentiment analysis will try to do. Sentiment analysis will also try to, for example, check the polarity. As I said, positive, negative, or neutral. Or it tries to discover what are the feelings and emotions. Is somebody angry? Is somebody happy? Is somebody sad? So when people buy products, you put reviews on social media, or you put reviews on the e-commerce site. So by looking at those reviews, these companies try to understand that is this customer happy with the product, unhappy with the product, angry with the, whatever are the features of the product, sad about it. What is that emotion, right? And sometimes intention also. Are they interested in the product, not interested in the product? So this is what in a nutshell, in a very concise way, what sentiment analysis that is used in text analytics tries to do. Now, how does it work? A simple example here. So, if you consider the following 3 customer responses, the first says, I love eating at Aroma restaurant because they have the best seafood, right? The second one is, the newly launched car is the ugliest car I have ever seen. And the third says, I love this iPad, but wouldn't recommend it to my friend. So these are 3 responses. Now, as a human being, when you read the first sentence, the person is very happy and has a very positive opinion about the Aroma restaurant. Second statement, person is very unhappy. Person has a negative opinion because the word ugliest is coming over there. And the last is also a bit negative, but it's difficult. It's more difficult for you to really understand what the person is trying to say. It's because, he says, I love the iPad, but still I won't recommend it to my friend. So it's very difficult for the software to, parse or understand these kind of statements. Whereas the first 2 is easy. The first is positive, the second is negative, right? So these are some of the, challenges that can come when we are doing sentiment analysis. But basically, sentiment analysis looks at the sentence structure, the adjectives. So look here, the adjectives. The ugliest, that's an adjective, that's bad, right? So best, that's an adjective, that's a positive one. I love, that's a positive sentiment, positive emotion. So it looks at structure, sentence structure, adjectives, adverbs, magnitude keywords, and a lot of this to try and understand what is the sentiment in that. What it tries to detect the emotions that are there. So it tries to detect emotions like happiness, frustration, anger, sadness, and all of this. Sometimes it goes wrong because people may express things in what do you call it, in third person. So it was not found to be good, so that's a third person. So that's where your softwares may find it challenging how to interpret these kind of things. And sometimes people actually use oxymorons. For example, people may say that I dropped dead on seeing the car, which actually, you and I will understand that the person loved the car so much, was so impressed after seeing that car. So, but look at the word, I dropped dead on seeing the car. So as human beings, we know that this is a very positive sentiment. The person is absolutely in love with that new car. But the software, because it is fed that dead is a negative word, it has a negative connotation, may actually interpret this statement or this emotion of the customer as negative. So these are some of the things that are there. Yeah, so I would want to take you through this, and probably I'll go back and then talk about some of the other slides which I've skipped. So this was a paper which I had done where, I called it the truth in exit interviews, and I tried to use qualitative analysis to this. So this was the scenario that was prevailing. And the scenario was the Fresho is an SME manufacturing company producing confectionery products like fruit juice, concentrates, jams, pickles, marmalades. Situated at Panchakini, it commands 24% of the market share. In the last financial year, the company saw very high attrition. A survey did not yield much information, and the company suspected the employees are not coming out frankly on the problems they are facing. So yes, there was a problem of very high attrition, and when they did a pulse survey, etc., the employees were not coming out and speaking. What is the problem? So the company decided to examine the exit interview documents of the employees who had left the company recently. And it was thought that the exit interviews would provide frank and maybe hard-hitting clues as to what is plaguing the company, what's going wrong, because the current employees are not coming out and speaking. They seem to be afraid. So let's look at what the people had said in the exit interviews. So when an employee decides to leave, he or she has nothing to fear and will come out with the ground facts without any apprehension. The exit interview transcripts were documented in the HR department. So people who had left, their exit interviews were recorded, so transcripts were made. The data was in text format, but it was deemed important to analyze the text document to diagnose the reason for high attrition in the company. So that was the line of thought which was there. The transcript of the exit interview, they were subjected to processing cleansing. Stop words were identified, so they were eliminated from the analysis. And then stemming was also applied, so that we were just considering the root word. And then we got a bag of words. So using that bag of words, a word frequency table was generated. Now there were many words, right? So based on the frequency, top 50 words were considered. You can go, if you want to have more granularity, you can go up to 100 also, depending, what you want to do. So I had restricted to the top, 50 words, and these were the words, this were the word length, this was the count, and this was the weighted percentage as to how many number of times this particular word was used in those exit interviews. From this, a word cloud was generated. So here you have the word cloud, and as you can see, the size of the word indicates the frequency, the number of times the particular word has been used. So you got work over there, you can see team over there, you can see leadership there, you can see poor, leaving, collaboration, somewhere you can see salary, you can see freedom, culture, sad, a lot of these things. So a word cloud like this emerged and restricted the word cloud to 50 most frequently used words. As I said, you can increase to more than 50 if you deem it appropriate. So that's up to you. What do you want? Further to this, with respect to these words, what was the sentiment that the people had? So the sentiment grading was done for all the exit interview files. So there were, some 31 files which were there. So the sentiment grading was done, and all of this the software does for you. And the software which I had used for this was NVivo 12. So it gives you a particular grading. It gives you these averages over here from where the sentiment index came out to be 0.12. Now, if the sentiment index is close to 1, it means the sentiment is positive. But if it is closer to 0, means the sentiment is negative. So here we've got very close to 0.12, which clearly said that the sentiment that was expressed in this with respect to the leadership, to the team, to the culture, to the salary was very negative. So yeah. So somewhere, after doing this sentiment analysis from the exit transcripted interviews, the management did realize that they would probably need to change the leadership. They probably need to, improve the collaborative work culture in the company. They probably need to give more flexibility to the employees. A lot of these issues are plaguing their organizations and contributing into people leaving the organization. So this was sort of one demonstration which I wanted to share with you with respect to using qualitative data analysis in HR. So I hope it's making sense. Right, so can we move forward?
Yes, ma'am.
Okay. The other scenario which I want to share with you is how you can use social media analytics for taking decisions. So this case dates back to 2020, and all of you would be aware of this case. It was on the news channels and it had rocked the world. So this particular exercise I had done during that time. So this was May 25, 2020. George Floyd, a 46-year-old Black American man, was killed in Minneapolis, Minnesota, during an arrest for allegedly using a counterfeit bill. Now, Derek Chauvin, a white police officer, knelt on Floyd's neck for almost 8 minutes while Floyd was handcuffed and lying face down, begging for his life and repeatedly saying, "I can't breathe." Officer J. Alexander Quing and Thomas Lane further restrained Floyd, while Officer Tao prevented bystanders from intervening. During the final 2 minutes, Floyd was motionless and had no pulse, while Chauvin ignored onlooker's plea to remove his knee, which he did not until medics told him to do. Eventually, George Floyd succumbed to that incident. But what happened after that was his death triggered widespread protests against police brutality, police racism, and lack of police accountability. And unrest began in local protest in Minneapolis, St. Paul area before quickly spreading nationwide and in over 60 countries internationally, supporting Black Lives Matter. So that's the slogan which came after this. And over 2,000 cities in the US had seen demonstrations as of June 13, 2020. Social media was live with the anguish people were expressing worldwide. So during this time, Twitter was alive with, tweets coming, some in support, most in support, and some against also from around the world. So from Twitter, these tweets, a few thousand, I don't remember exactly how many I had, but a very large number of tweets I had downloaded and again subjected it to text analytics. So in such a scenario, social media analytics was conducted by gathering thousands of tweets from Twitter and subjecting it to analysis. Again, the same thing, a word cloud was produced and a sentiment analysis was done. Now, because the tweets were into thousands, there is a facility of auto coding. So auto coding was, that feature was used, and after using that feature, sentiment analysis was used, and this is what we got. So we got a word cloud which looked something like this. This came from the tweets which were on the Twitter. So there was a date, particular date that time, a particular window during which I had collected these tweets, and this is the kind of word cloud that I had got. Further to this, sentiment analysis gave me this graph. So as you can see, very negative, moderately negative, then you have moderately positive, and then very positive. As you can see, the graph for very negative and moderately negative is very, very high, and for moderately positive and positive is extremely small. So by this, it gives you a sense that the Twitter was live with tweets that were in support of the Black Lives Movement, and very few people who had an opinion which was different. Also, the spatial analysis, from where are these tweets emerging? So spatial means space, right? So from which parts of the world these tweets are emerging? So this particular graph is there, which tells you, as is expected, majority, the heaviest concentration of tweets is, of course, the US, because that is where it had happened. But it had spread across the shores and reached Europe. So as you can see, there is a heavy concentration in Europe also. So if you can recall that incidence, and if you can recall, if you were following the news at the time, there were heavy protests in France. There were heavy protests in Germany. That happened. So this movement, which started in a small town in US, crossed the borders and had started reaching global proportions. You can see that happening in Europe. There are some tweets many tweets which are from Central America, few from South America, very few from Africa. India, of course, figures there. Mainly from India. Then you have from Australia, few of these islands. And interesting to note that there were no tweets from China. There were no tweets from Russia. There were no tweets from, this part of the world. So, but this also sort of tells you the geographical spread of the originating tweets. So this, can be used for understanding the sentiment of people and probably can help the administration decide its strategy, because sentiment is important. All of this is about emotions. Emotions were flying very, very high. So an analysis like this can aid the administration decide what future action they should be taking. It should be helpful in that. So that's how social media analytics can also be used for taking administrative decisions. Coming to so I still have some time. I'll go back and cover these slides for you. Some of the applications which all of us know about text mining. So social media, they use it to predict the customer needs. Resume filtering. So, if you have ever wondered when you send to naukri.com or to shine.com, what do? So they have, they specify that if these keywords are present in the resume, it's filtered to be considered. Otherwise, it is rejected. So again, here text mining is being used for filtering of your resume. Spam filtering. So if you have ever wondered, why automatically some of the mails go to the spam folder and they don't come to your inbox, because again here the software is learning that which are the ones you don't open, which are the ones you never seem to be interested in, and after some time will automatically move this to the spam folder. Other than this, certain words, if they are contained in the mails, they would be moved automatically to the spam folder. When you are doing research and you're using a questionnaire for collection of your primary data, now generally, one question at least we keep, which is an open-ended question where we want to capture the opinion of the people. So how to analyze this open-ended questionnaires? Again, you can go in for text mining. It will help you identify themes. If there are some themes over there, it will help you identify the sentiment of people with respect to whatever you are studying. So analyzing open-ended survey responses. Automatic processing of messages and emails. These are also some of the applications of text mining. Right. Finally, we come to the last topic is, so you've done your analysis, you've done your analytics, but now the job is to convey all of this in a nice, crisp, concise, precise manner to your stakeholder. So how do we do that? So you need to have a dashboard. So just like you have a dashboard in a car, which tells you about all the key parameters of your car. What is the fuel? How much of fuel is left? How much of your coolant is left? What is the speed at which you're going? How much of brake fluid is there, etc. Right? So likewise, in the context of the HR function, also the key metrics that you have can be included in the dashboard, and this dashboard can then be presented to your CEO for any kind of approvals or for getting budget sanctioned and all of that. Now, today's time, these dashboards have become dynamic in nature. For example, you can actually drill down and drill through. So you have, for example, you have turnover data. So that's a metric which you have used. Now you want to know that is this turnover data different for my male employees and for my female employees? So, you know, your dashboards can be dynamic where you can, you know, put the filter. You only want to see the turnover for female employees. Then you may want to see the turnover for male employees, right? So many, you know, softwares are available today, which will help you create wonderful dashboards. Your MS Excel itself gives you the facility to create dashboards. You can also make use of Power BI that gives you very good looking, very aesthetic dashboards that you can create. You can also use Tableau. So a lot of softwares today are available which will help you create dashboards. But what is important to understand, what are you going to put on the dashboard? What key metrics are you going to put on the dashboard, right? So you should not be putting the less important ones. So all the important KPIs, they should be there on your dashboard, and it should not become too cluttered. Remember, dashboards are being created so they give, you know, in one glance an important assessment of the state of affairs. So it should not be too cluttered, and it should not have KPIs which are not significant. And it should have KPIs only and not indicators which are not significant. If it is dynamic, that much better for you, because then you can actually slice and dice. You can actually drill down and get to the bottom of the problem. So when you're creating a dashboard, some of the things that you can keep in your mind is narrow down what you measure. The dashboard should display only the key metrics. The idea of dashboard is to sift through the clutter and focus on the compelling metrics required for strategic decision making. So while there is no number prescribed as to, you know, there's no formula that you should have 10 or 5 or 7 metrics only, but 8 to 12 is a good idea, right? Because if you have too many, then the focus is lost and there'll be too much of clutter. Measures only relevant and meaningful data. So to influence strategic decision, data should be actionable. That's important. Dashboards should support database management of business issues. Then if you dive deeper, businesses should strike a delicate balance between measuring everything and measuring nothing. See, often, you know, we may become very zealous. So when we hear analytics is the thing of the future, we may become overzealous. For everything, there has to be a sound logic, right? So you should not, you know, get carried away and you know, try to measure everything. This is also there, let me measure this. This is also there, let me measure this. You'll be lost. So you have to, you know, take that very important decision that this is what needs to be measured and this is what can be ignored. At the same time, you will have to fight the temptation, particularly the HR professionals, that you don't want to measure things. You know, often we feel, oh, everything can't be captured in numbers, and HR is so intuitive. HR is about people. How can you define people and people issues in numbers? So this is the emotion, or this is the thought process a lot of HR professionals may be having. But please understand, for better organizational outcomes, for better business outcomes, we do need to measure. What gets measured gets managed. That's a cardinal principle we all have lived with. So we will need to strike that balance that yes, we need to measure, and we need to measure the important things. So these are some of the points that some of the tips which you can consider when you're creating an HR dashboard. Here is an example. This has been picked up from the net. So, you know, so as you can see, this talks about the different years, and there's a drop down arrow. So you can select for which year you want to see this, for which month you want to see this, which type of customer you want to see this. Then you got salary, then you got average salary, then you got what's the number of employees, and then broken down in terms of the gender diversity that you have there. What is your overheads ratio? What's your revenue per staff? Education spending, and education per head, sick leave, overtime ratio, regional split. And so this is a snapshot from Power BI. that's been taken here. All these graphs are available there, and you can come up with this beautiful dashboards. They look nice, and they also communicate in one glance all the important information that you would need to take decisions with respect to your HR domain. This is another example here. This is also an HR employee dashboard where we're talking about employee cost over sales revenue. So you got a line graph there. Then you got satisfaction surveys. You can drill down. You can click each metric to drill down by department. So if you want to know the satisfaction survey department wise, you can just click over there, and for every department you can drill it down. You can understand how it is. Employee engagement by department, then employee gender split, employee status, how many of them are full-time, how many of them are part-time, then internal promotion rates, average employee tenure, management to staff ratio, employee turnover rate, click to drill down, employee absenteeism rate. So another example here we have where you can use these dashboard. So all in all, a lot of benefits of using HR analytics. Helps you take better decisions. It creates the business case for HR interventions. So, if you go with this kind of data, if you go with this kind of a dashboard, definitely the top management, the CEO is going to approve budgets for your various HR interventions. No more will they say this is HR as a cost center. HR very much is a strategic partner impacting business outcomes. But you need to be, hands-on with these HR analytics so that you can make your business case. Test the effectiveness of these interventions and move from just being an operational partner to a tactical or even a strategic partner. So some of the benefits of HR analytics that you can have here. Challenges, of course, many of them. Firstly, difficult to find people within the HR domain who will have the competency to deal with HR analytics. It's still very nascent, still early days. Yes, people are picking it up. It's becoming popular by the day. So organizations also should consciously try to develop these, analytic competencies in the HR professionals. On the data front, getting data which is clean, getting data which has got quality, being able to extract relevant data from the piles and piles of data on which the HR department sits, to other issues like data privacy, compliance to the norms, and identifying which best technology to be used. Now you have got a whole lot of technologies, but as I said, for everything you should have a sound logic, sound business, not because the competitor is doing it or because the world is talking about it, because there is so much of buzz about it, we should also go ahead and do it. No, it has to make business sense for your organization. So these are some of the challenges which the HR professionals face. My last slide with you. When you're doing HR analytics, few cautions to be observed. Avoid inversion of means and ends. So go back to the LAMP model which we had discussed. HR analytics is the means and creating value is the end. So why are we using HR analytics to create value for the organization? HR analytics should not become the end, right? So that inversion should not happen. Avoid measuring what is easy, but focus on measuring what is right. So you need to search for the car keys where they were lost and not where there is light, right? So avoid measuring what is easy, but focus on measuring what is right. Analytics should keep measures simple and focused on decisions. And here I would want to quote Dave Ulrich, who says that the ownership and accountability of HR analytics should be kept with the line managers. Right? So it is not just the HR professionals who should be accountable. The line managers, because they are the ones who are executing the decisions and you are taking decisions based on analytics. So the ownership, in the opinion of Dave Ulrich, should be kept with the line managers. And whatever necessary investments have to be made into HR analytics in terms of, IT infrastructure, in terms of developing HR professionals, helping them develop the required competencies to understand business also. So HR people also need to understand the business model. Along with that, the analytics, then only will they be able to impact, or take decisions which are going to impact the business outcomes positively. Right? Some of the references which I have used, you can refer to some of these books. Some of, they have got good examples, good understanding is there. My own book is also there. You can refer to that if you feel like. It's a Sibgen learning. And the Predictive HR Analytics, Mastering the HR Metric is a wonderful, wonderful book by Martin Edwards, Kirsten Edwards. And the other book which I like is the Practical Guide to HR Analytics, Using Data to Inform, Transform, and Empower HR Decisions by Valerie Streets and Shauna D. Walters. This is again is a wonderful book you can refer to if you want. That's all from my side. Thank you so much. If there are any questions, I'm most willing to take them. Right, so do we have any questions? Anybody want to say anything?
Hello, ma'am.
Yes.
Good afternoon, ma'am. Thank you very much for your informative and insightful deliberation. But, ma'am, I have a small query. Could you please suggest a few examples of application of text mining analytics or any other kind of qualitative technique application in corporate social responsibility practices effectiveness? How effective corporate social responsibility practices are going on or their management in this regard?
Right. So what you can do is, if you're trying to study the corporate social responsibility in a particular sector, probably you can conduct interviews with the leadership, in that sector, and then subject those interviews to text mining, where you will be able to identify, are these people thinking on common themes? Is it that people are thinking about the environment more? Or is it that people are thinking about, health-related issues? Are people thinking about women health-related issues? So you can analyze these interviews, and you can convert the into transcript and then subject it for text analysis. So that will help you identify that, let's say in the IT sector, what is the leadership's point of view with respect to CSR initiatives?
Okay, okay. Thank you, ma'am.
Any other question? Yes, participants, any other question? I guess, ma'am, no question. So thank you very much, ma'am, for the another session. And it was, I'm continuously getting feedbacks that it was very informative session. So all must have enjoyed your session, especially because this session was based on qualitative data. Ever since we were working on only quantitative data all through. And this you just throw some light on how qualitative data can be useful and how we can use qualitative data for our research work further. So that is really something very unique these days across. I mean, especially in these 5 days that you actually took this particular point, how to take qualitative data for our research and to get some better insights out of it. So thank you, Dr. Srivastav.
Thank you very much, Pranjal sir. Thank you for the opportunity. I had a wonderful time and I hope I could add some value. Thank you all the participants. Yes. Thanks a lot.
Thank you. Thanks a lot.
Thank you, ma'am.
Yes, so participants, now we are closing this for the day, and tomorrow 9:30 we are meeting up for the last 2-3 sessions. Professor Brijesh, would you like to add something?
No, sir. I just want to remind everybody that they have to make provision of 1 hour for their end term examination. So 4:30 to 5 we'll have our valedictory, and 5:30, I mean sorry, 5 o'clock we will post the link. 4:55. From 5 to 6, the faculty members will be having their assessment. And please remember, you have to score 60%. Okay, it will be MCQ based, and you have to score. Yeah, we'll have 40 to 50 questions. We have to yet design the assessment. We have received the MCQ from all the research projects. So we'll design the MCQ, 45 to 50 MCQs, 1 hour, and you have to score 60% of the marks, 60% marks to get entitled for the certificate. That's all from my side, sir.
Okay, sir. So we are calling it a day. Yes.
Hello, Pranjal sir.
Yes, Sujit sir. Tell me.
Sir, two query. One is, sir, in AICTE scheme, I do not find my attendance.
Where?
In AICTE training and learning, that particular website, sir, where we can find the attendance. See.
So see, sir, attendance and everything will be uploaded at the end. It's not every day's thing. It will be updated because we have to upload all your exam marks and the attendance both, so that you will receive the certificate from there.
Okay,
it
sir.
is not day-to-day job.
I thought it's on daily basis you are.
No, sir. No, sir.
Okay.
Because there are 100 participants, no? So if you have ever done this until FDP work, so it is just one-to-one, uploading every day. So it's a very huge job. So it is usually done at the end of the.
Definitely, sir. One more thing, sir. Can we get, sir, recorded video of the classes so that we can get
that is
more
what
prepared for the examination?
I know. That is what we have prepared it today. So I have actually prepared one document with the session-wise link of all videos. So these videos are there in the Google Drive.
Actually, sir, before, if possible, sir, tonight, if possible, only PPT slides of different experts, if you can provide all of us, then definitely we can.
We have already requested all of them. I and Brajesh sir and 1-2 more faculties, they are ready to give their PPTs. So we are sharing those PPTs by the evening, today evening only. And although I think in the classroom, if you are, you are there in the classroom, so you must have found our PPTs. I and Brajesh sir's PPTs are very much there. We have already shared them. Yeah, other professors we are also roping in. We are also telling them to give their PPTs. So it's basically on them whether they want to give their PPTs or not. But we have already requested them. If they provide us, we will definitely share it with you.
Thank you, sir. Thank you very much.
Yes. Recordings, whatever we have, got these recordings until yesterday, because today's recording will be in the process until yesterday. Whichever recording we have, we are soon going to share that document with you as well, so that at least you can see the recordings. Okay, and today's and tomorrow's recording will.
Yeah, I think we have lost. Yeah.
Okay, so it will take time. Otherwise, we are going to provide you whatever material we have, processed so far. So by evening, you will get everything in the classroom and on the WhatsApp group as well. Okay. So thank you, guys. Thank you all professors. We are meeting tomorrow at 9:30. Till then, goodbye and have a nice evening.